first year. So in this case, for example, it's 2021 until 2022, or only 21, 22. So we already have the first one. So we only have to create the second one. And we can get this structure of year 1 and year 2 together by concatenating the seasons. So here I'm going to show you how to do it. So first we have to make this a string, because right now it's a number. And if we want to concatenate this object has to be a string, not a number. So now to concatenate, we use this plus operator and then write str again, now parentheses, and now season plus 1, because the first one is the first year and the second one should be the year plus 1. For example, here 21, 22. So now I run this and let's see the result. So here, as you can see, we got 15, 16, 16, 17, and so on. So now instead of writing 21, 22, that only allows us to extract the CSV files from this season, we're going to copy here this and we're going to replace it. So here we delete this and paste that. So here we have the format we wanted, but now the values are going to increase with this for loop. So first it's going to be 15, 16, then 16, 17, and so on. And we're going to get the CSV files from the past 6 seasons. So that's what we wanted. So now we have to add one more little detail here, and this is a new column, because here the data frames don't have a column that help us recognize what is the season that this data frame belongs to. So for example, here in this data frame, we don't have a column that says season or year. We only have the date. So to easily recognize which season corresponds to a data frame, we're going to add a season or year column. So here I'm going to do that with the insert method. So we've seen different ways to add a new column, and we're going to use here the insert method because I want this new column to be in the index 1. And the insert method allows us to put a column in a specific index. So now I'm going to show you here. I write df.insert, and here we write the index we want to put this new column. So here I want it to be in index 1. Then we have to write the name of the new column, and I'm going to name it season. And then we have to introduce the values. So here I only want this season column to have the value of the first year, or well, the first season, let's call it. So I only want this. I'm going to show you here. I only want the first one. So the first year, that in this case is 2015 or only 15, I want it to be in this season column. So not the second one as it was here. So only the first. So here I'm going to write season, and I'm going to get this because I'm doing here a for loop through this range. So this is going to be in my season column. And finally here, to avoid making the video so long, I'm going to delete some of the elements so we get fewer CSV files. So here I'm going to get rid of some of them. So for example, here E1 and then EC, because before there were 5 and here there are 6 seasons. So 6 times 5, we're going to get like 30 CSV files, and it will take some time. So now with 3, it's going to be faster. And now you can also remove this encoding argument because it's going to work fine with these 3 seasons. So it's only for the sake of this video. Now I'm going to run this code, and let's wait a couple of seconds until this is done. All right, the execution was finished, and now we can see the content inside the frames list here, and we're supposed to get 18 data frames because there are 3 elements here and 6 seasons here, so 18 in total. So let's verify this by using the length function. I use length, and here we got 18, so it's correct. We have 18 data frames. And now I'm going to show you here the first data frame. So here I write frames, square bracket, 0. And we're supposed to get the data frame of league E0 from season 15-16. So let's check. Here I run. And as you can see here, we have the season 15, so it's correct. And the league is 0. So yeah, it's working fine. Now let's check fast the last element. So there are 18 elements in this frames list. So the last element should have the index 17. So here I write frames, square bracket 17, and we get the season E3, the season 20 and the league E3. And let's check here. So E3 is the last element and the last season is 20. So here 20 E3. So yeah, it's correct. And that's it. In this video, we learned how to extract multiple CSV files using pandas. Okay, in this video, we're going to store all the data frames extracted with pandas into a dictionary. Dictionaries help us properly manage data. And in this case, I created a dictionary called dict_countries, and I have as key the name of the league, the actual name of the league, and the value is the code that this website uses for each league. So for example, Premier League has the code E0, and Championship, I think it has E1. So here we have the original name of the league, and here we have the code. So if we want to get access to one code, for example, we want to get SP1, we can write only the name of the key. And since it's a dictionary, we're going to get the name of the value. First, here I'm going to run this dictionary, and now I'm going to run this one. And here, as you can see, I got the SP1 because this is the value of the Spanish La Liga key. And the same way I created this dictionary, I'm going to create another dictionary, in this case called dict_historical_data, to store all the data frames that we extracted here in this previous video, where we extracted multiple seasons and CSV files of multiple leagues. So all of that is going to be stored into a dictionary. So we don't have to use the list indexes as we did in the previous video, but only use the key that represents the actual name of the league. So the first thing we're going to do is to copy the code here that we used to extract CSV files from multiple seasons and leagues. So I'm copying this that we created in the previous video, and I'll paste this here. So I paste it here, and now I'm going to modify this one, and we're going to loop through key elements. So here, before we looped through a list, which is this list, but now we're going to loop through a dictionary, and it's going to be this dictionary I created before. So here I'm going to write for league in dict_countries. So this dictionary contains some leagues like Spanish La Liga, Bundesliga, and English Premier League, and also the codes of each league. So for example, English Premier League has the code E0, and I got these codes manually, and you can get these codes yourself by going to the website and copying the link address, and then you're gonna get, for example, SP1, D1, and any code of any league you want. Now I'm gonna show you what we get when we loop through a dictionary, because here we're looping through a dictionary. So just a recap here. So for league in dict_countries, now I'm going to write print league. So let's check what we get here. If we print this, we get the keys. So Spanish La Liga, German Bundesliga, and so on. So these are the keys. But if we want to get the values, we have to use this syntax to get the values of a dictionary, which is this. And now Control Enter, and we get the values. So as you might remember, this is the syntax we use to get the values. So now we can use this syntax to replace the name of the league or the code of the league. So here I'm going to show you this league variable represented the code of the league here. Before we use this leagues list that I'm going to uncomment. So we used this leagues list that contains these codes, and we loop through this list. So this represented E0 and E2 and E3. But in this case, we don't have the leagues list anymore. And now we're using a dictionary. So to get the same codes, we have to use this syntax. So we're going to replace this league variable. So I double click here and I delete, and now I paste this new syntax of the dictionary. So I copy now, and now I paste it here. So now this link here is ready. And now the first thing we're going to do is to concatenate all the seasons that corresponds to a same league. So for example, if we have the Spanish La Liga, we have to concatenate all the seasons from 15 to 20. So to do that, we only have to use the concat method. We didn't use this method so far, but this is really simple. So I'm going to explain you how it works right now. So to use the concat method, we write pd.concat, open parentheses, and now we have to write the object we want to concatenate. In this case, what we want to concatenate is this frames list. So I copy this and I paste it here. And as you might remember, this frames list contains the data frames of all the seasons that we got here in this range. So 15, 16 until 20. So by doing pd.concat, we can concatenate all the seasons from the season 15 to the season 20. So all of them will be in just one data frame. So I'm going to assign this to a new variable that is going to be df_concat. So this one represents to all the data frames we concatenated. So all the seasons from season 15 to season 20. So now it's in just one data frame. And by the way, we put it here outside this for loop, because if it's inside, I'm gonna do it here. If it's inside this for loop, we're not letting this frames list to append the data frames from season 15 to season 20. So what we have to do is to put it outside this for loop that iterates over the seasons. And now that we have this df_concat that represents all the seasons of a league, we can assign this data frame to a dictionary. In this case, I created this dictionary, as I told you before, dict_historical_data. And this is going to be my dictionary that contains all the data frames I want. So here, I'm going to assign this by writing the name of the dictionary. And now I open square brackets. And now I write the name of the league. So in this case, the name of the league is stored in this league variable. And then I set this equal to the df_concat. So what we're doing here is assigning a key that has the name of the league. And this key is going to have a value. And this value is going to be the df_concat. So the league is going to be the key, and the df_concat is going to be the value. And the df_concat contains all the data frames from season 15 to season 20. Great, this is almost done, but now we have to make one little change. Here we have to put this frames empty list inside the loop. So here, and now I'm going to explain you why we have to do this. So if this empty frames list is created outside the loop as it was before, what is going to happen is that here, when we append a new data frame, we're going to accumulate all the data of the previous league. So for example, we start with Spanish La Liga, right? Then we iterate for season 15 to season 20, and we get all this data and we concatenate it. So that's fine. But then when we go to the next key, for example, German Bundesliga, what it's going to happen is that the previous data of Spanish La Liga is going to be here. And when we concatenate this with the concat method, we're going to get a data frame that contains the data of the Spanish La Liga and also German Bundesliga. And we don't want that. We want the data frames to have independent leagues. So what we have to do is to delete the data of the previous league. And we do that by introducing this empty frames list inside the loop. So here, every time we iterate over this dictionary, we're going to create a new frames empty list. And now when we go over the second iteration, for example here, German Bundesliga, here when we get to this line of code, the frames object is going to be an empty list. So this means that all the data that was stored for the Spanish La Liga is going to be lost. And that's what we want. But all the data is actually stored in this dictionary. So we are not actually losing the data. We're just removing the data from the frames list. But all the data is stored in this dictionary. Great. Now everything is ready. And now I'm going to run this code. So now I press Ctrl Enter. And now let's wait a couple of seconds or maybe 1 minute. Okay, now the execution is finished. And now let's check the data that was stored inside this dictionary I created here. So now I'm going to show this and we see the data inside this dictionary. However, it's not readable. So here first I'm going to show the keys of this dictionary. So I write keys. This is the keys method. And as you can see here, I got the keys. So the keys are represented by the actual names of each competition. So I have Spanish La Liga and English Premier League. So to get access to one of those data frames, we only have to use the syntax to get a value from a dictionary. So for example, let's say we want to get the English Premier League data frame. So we only write the name of the key, in this case English Premier League, and that's it. Now I run and we got this data frame that contains the data of season 15, 16, 17, 18, 19, and 20. And also we can see that this is English Premier League because here we got the E0, that is the code for this competition. And as you can see here, this is an easier syntax than writing the index because the index actually doesn't tell you much about the data. So in most cases, it's more convenient to use a dictionary to store data frames because we can use keys and it's easier to memorize a key name. And it's not so easy to memorize an index when we store data frames inside a list. And that's it. In this video, we learn how to manage all the CSV structed with dictionaries. Okay, in this video, we're going to learn how to filter a data frame based on one condition. In Pandas, we can filter a data frame based on conditions, just like on Microsoft Excel, but here we use methods. So let's start by importing Pandas as usual, import Pandas as PD, and then we're going to use a different data frame, and in this case is a laptop price data frame that I have here, and you can download this data frame in the notes in the description. You can find it there, and we're going to read it with the pd.read_csv. So I'm using this method and I'm assigning this to a variable named df_laptops. So that's going to be my variable. So now I run this code, and now let's see the first 3 rows. So here we have the first 3 rows of this data frame, and now let's check the columns that this data frame has. So first we have the ID. Usually IDs are unique, so you won't find duplicate values. And then we have the companies. Here is the name of the company that this product belongs to. Then we have the name of the product. So here we have MacBook Pro and other types of laptops. Then we have the type of the laptop, so Ultrabook, Notebook, and so on. Then we have the screen size. So this one is in inches. And then we have some other values that we're not going to see so much, like the screen resolution, CPU, RAM, memory, GPU, and some others. But this one, price in euros, we're going to use it. So here are some of the columns we're going to use to filter the data frame in this course are the price in euros here, and also the company, and the product, and some others like the screen size in inches. So this was just a little review of this data frame. And now let's filter the data frame based on one condition. So to see how to filter a data frame in Pandas, let's solve this task that we have here that says find which rows have the word Apple in the company column. So we have to make like a comparison. We have to compare two objects. So here we have to compare the company column with this string that is Apple. So in Python, as you might know, we compare with the equal sign. So we write the equal sign twice, and this means comparison. So this is like we're comparing two values. For example, if I write here 1 is equal to 2 and we run this, we get the value of false because these two values are different. But now if I write 1 is equal to 1, now we get true because these two values are the same. And the same way we compare numbers, we can compare other type of objects like series. So here we can write the name of a series. So for example, I can write the series of the company column. So here I write df, and now I'm gonna copy the name of the data frame. So I write df underscore laptops here, and then to create a series, also known as a column, we open here the quotes and then we write the name of the column. So this is a series, the company series or the company column, and we have to compare this to the Apple string. So we write Apple and we're comparing these two values. So here we want to know if the values inside the company column are equal to Apple. So for example, let's go to the data frame, and here in the first row, it's going to compare. For example, Apple is equal to Apple, then true, because those are the same. So we get true. Then the second, Apple equal to Apple, true. And then the third one, Apple equal to HP, and then we get false. And that's how we're going to build this new series, because we're going to get from this a new series of values that are true or false. So now let's verify this. So I'm going to run this one. And as you can see, we got the values of true and false. So the first three values are true, true, and false, because Apple is equal to Apple, true, then Apple equal to Apple, true, and then the last one is different, so false. And that's how all the rows were filled. So now that we got this series, we can filter the data frame based on these results. So to do that, we have to first copy this code, and now I'm going to paste it here. And now to filter the data frame, we have to follow the following syntax. So first we write the name of the data frame, and then we put this code inside square brackets. So write square brackets, and this is the syntax. So inside the square brackets, we write the condition, and outside we write the name of the data frame. This is the syntax. So now let's filter this data frame based on this condition. So I press Control Enter, and now let's see if the data frame was filtered. So here I got this result, and let's verify if all the values inside the company column are Apple. So here it says Apple, and let's scroll down. All of them are Apple, and yeah, all of them are Apple. So we successfully filtered this data frame. Now I want to give you one tip. So sometimes when we have larger data frames, it's not so easy to verify that all the values have this type of string. So for example, here we could easily check that all the values were Apple because it's a small data frame. But for bigger data frames, this is not gonna be so easy. So in those cases, we can use the value counts method, and I'm gonna show you how to do it here. So we actually already learned what the value counts method does, but in case you don't remember, the value counts method counts all the values inside a column. So here we only have to write that value underscore counts, open parentheses, and inside we write the name of the column. So I write company. So write company, and then we run this, and we got here that there are 21 rows with the word Apple in the company column. So we can easily see the categories inside the company column. And that's it. That's how you filter a data frame based on one condition. Alright, now is your time to filter a data frame based on one condition. So here I made two exercises that will help you practice what we learned in this video. So the first exercise consists in finding which rows don't have the HP in the company column. So this is similar to the example we've seen in the video, but in this case it's like not equal to, but is the different symbol. So once you build the code of this condition, you have to filter the data frame as we did in the video. And then in the second exercise, you have to find the laptops with price over 2,000 euros. And in this case, you have to use a different column. So here you have to use the column price underscore euros for exercise number 2. And for exercise number 1, the company column. So now you can pause the video to solve these two exercises on your own. And after you finish them, you can continue watching this video to solve these exercises together. Okay, now let's start solving these two exercises, and let's start with exercise number 1. So here we have to find which rows don't have the HP word in the company column. So this is similar to the example we've seen before. Before we use the equal sign to compare two objects, but in this case we have to use the sign that represents not equal to. So here I'm going to show you. So this one is equal to, the sign equal to, and this one is the sign not equal to or different. So we have to write this exclamation mark with the equal sign. So let's test it out. I write 1 not equal to 2, and it says true because these two values are different. But now 1 not equal to 1, and now it's false because these two values are equal. And now we're going to compare the series with the string. So here I write the name of the series, which is df underscore laptops, and then open square brackets. Then we write the name of the column, in this case company. And then here on the right, we have to write the name of the brand, in this case HP. So here we're comparing these two values, and I almost forget, I need to write the exclamation mark. So now it says this series is not equal to HP. So we're comparing that. Now I press Control Enter to compare these two values. And now we got the the result that is a series. So now let's verify very quickly the original data frame. I'm going to show only the first 3 rows. And now let's compare quickly. So HP is not equal to Apple, then true. So we got true. Then again, HP not equal to Apple, true. And then HP not equal to HP, false. So everything is correct. And we got here the result, and we have to introduce this inside square brackets to filter the data frame as we've seen before. So here we write the name of the data frame, square brackets, and inside square brackets, this condition. Now we run to filter the data frame, and we get this new data frame. And here in the company column, we get all the companies except for the HP company. So here we can see that there is Apple, Acer, Lenovo, and other companies, but not HP. So now to verify which companies are in this column, we can use again the value counts method. So let me write it here, parentheses, and inside the name of the column we want to count. So here I press Control Enter, and now we can see how many rows have the value of Lenovo and Dell and so on. So we can see that there are a lot of Lenovo laptops, but none of them are from HP because we used this condition. So we filter HP out. Okay, now let's solve the second exercise. And here we have to find laptops with price over 2,000 euros. So in this case, we have to compare with this sign that is greater than. And in this case, it works like this. So we write 1 greater than 2. For example, here we got false because 1 is not greater than 2. But if we write 3 greater than 2, it's true. And that's how it works. So here on the left, we write the series name. In this case, I'm just going to copy here this syntax. And now I'm going to paste it here. So here, this is the series, also known as column. And here, instead of writing company, I'm going to change it for the price column. So I'm going to copy this column, which is price underscore euros. So I copy this, and now I paste it here. So here I have my column price euros. Now on the right, we have to write the 2,000 euros here. So here I'm going to write the number 2,000, and that's how we're comparing. We're comparing the price underscore euros column with this 2,000 value. So we're going to see which values inside this series are greater than 2,000. So let's press Control Enter and let's find out. So here we can see that the first 3 values are false, so they might be less than 2,000, and the fourth is true, so this one is greater than 2,000. So now let's filter the data frame with this syntax, and let's run this, and let's verify very quickly the values in the price in euros. And here, as you can see, all the values in this column are greater than 2,000. And that's it. I hope you successfully solved these exercises. All right, in this video, we're going to learn how to create a column based on one condition using the where method. So here, first, we're going to start by importing pandas as usual and reading the same CSV file we worked with in the past video. So here we have the same CSV file. Now to create a column based on one condition, we have to import NumPy because this where method belongs to NumPy. So here we import NumPy as NP and we run this one. So here to show you how the where method works, we're going to create price tiers based on the price euros column. So here we're going to use this column and we're going to compare these prices with another price to determine if this is either cheap or expensive. So let's use the number 2000, and let's say that if a laptop costs more than 2000, this is considered expensive, and if it costs less than 2000, it's considered cheap. So here we can create this with a condition. So as you might remember from the previous video, we make conditions by comparing two objects. So in this case, I'm going to compare this price underscore euros series. So I write df underscore laptops, and then I write the name of this column and I put it inside quotes. So now I have this series, I'm gonna run it, and now we have to compare this with the value 2000 as I told you before. So if this is greater than 2000, then this is gonna be true. And now we're going to compare these values one by one with the value of 2000. So for example, the first one is less than 2000, so the first one is supposed to be false. So here I run this and we got the first value of false. So now this is what we learned in the previous video, but now we're gonna use the np.where to determine which value is gonna replace the false and which value is going to replace the true. So I'm going to show you here. I write np.where, then open parentheses, and inside the first argument is going to be this code. So the condition. This is our first argument. Then the second argument is going to be the value we want to set when this condition is true. So when this is true, I want to set the value of expensive. So it's going to be expensive when this is greater than 2000. And the third argument is the value we want to set when this is false. So when the value is less than 2000. So in this case, I want to set it to cheap when it's less than 2000. So the second argument is the value when the condition is true, and the third argument is the value when the condition is false. Now I'm going to run this one, and as you can see here, we don't have anymore the true or false values, but now we have the values of cheap or expensive. Well, here we only have cheap, but this is only the summary. If we check this array in detail, we will find many expensive values. And now we can set this array to a new column as we learned in this course. So first, to create a new column, we write the name of the data frame, in this case df underscore laptops. And now I write these square brackets, and now I write the name of the column I want to create. In this case, I'm going to name it price underscore tier. And now I'm gonna set this equal to this array. So I copy this one and paste it here. So now my new column will have the value of this array, which is here. So now I'm going to run this cell, and now I'm gonna show the first 5 rows of the df underscore laptops data frame. So here I use the head method, and now we can see the first 5 rows. Now, if we go to the last column, here we have a column named price tier. And this one has the values of cheap or expensive. So let's verify fast the condition. So here, the first one is less than 2000. So we got the value of cheap because this one is false, so it's correct. And this one is greater than 2000, so we got the value of expensive, and this column was successfully created. Now we can count the values inside this new column by using the value counts method. So to do that, we only write the name of the data frame, then we write value underscore counts, then open parentheses, and now the column we want to count. So here the column is price underscore tier. So now I run this one, and we can see that almost 1,100 laptops are considered cheap, and only 137 laptops are expensive. And that's it. That's how you create a column based on one condition with the where method. Okay, now is your time to create a column based on one condition with the where method by solving this exercise. In this exercise, you have to create an array based on the screen size. So in this one, you have to use this inches column that is right here, and you have to compare the values. So let's say that if the size of the screen is greater than 15 inches, we can say that the screen is big. But if the screen size is less than 15 inches, the screen is small. So here I'm gonna say if the screen size is greater than 15, that's gonna be the condition. So here is the condition, and you have to create an array based on this condition. So you have to do this as your first task. Then you have to set this array as a new column, as we did in this video. And then you have to show the first 5 rows and count the values inside this new column that I'm gonna name it screen underscore size, but you can name it as you want. And that's it. You can pause this video and try to solve this exercise on your own. And after you finish this exercise, you can continue watching this video to see my solution. Okay, to solve this exercise, I'm gonna create first a condition that says that the screen size is greater than 15. So first I write the name of the data frame, df underscore laptops. Then I open square brackets and I write here the name of the column inches. So here I write inches. Then I compare this with 15, and this is gonna be my condition. So here we got the values of false and true. And now if we use the where method, we will be able to replace these values of false and true for the categories we want. So here I'm going to write as first argument this condition, and then the value when this condition is true. So if the screen size is bigger than 15, the value that is going to be assigned is big. And if that's false, so if the screen size is less than 15, the value is going to be small. So this is my array that I'm going to create here. And I have here an array that contains the values of small and big. Now I'm going to set this to a new column. So I write here the name of the column that I want to create. So it's going to be named screen underscore size. And then I'm going to set this to this array. So I copy this one and paste it here. So this array is going to be set to my new column, screen size. Now I'm going to show this this data frame, the first 5 rows of the data frame. But first I run this code, and here I got an error because I didn't write the S here. So I wrote the S, and now I run this one and everything is okay now. So now I'm going to show the first 5 rows. So I write this and use the head method. And as you can see here, I have here the first 5 rows. And if I go to the last column, here we have the screen size column. So let's quickly verify if it was successfully created. So here in the size, the first value is less than 15. So this one is supposed to be false. So we should get the value small, and it's correct. And now the third one is greater than 15. So this one is true, and we should get the value of big. And yeah, we got big. So this column screen size was successfully created. Finally, let's count the values inside this screen size column. So here I'm going to use the value counts method. So I write value underscore counts, open parentheses, and now I write the name of the column. So I'm going to copy here and I paste it here. Now I run this one. And as we can see here, there are 835 laptops that are considered big and 468 are considered small because their screen are less than 15 inches. And that's it. I hope you successfully solved this exercise. Alright, in this video, we're going to learn how to filter a data frame based on 2 or more conditions. So to start with this, let's import pandas and read the CSV file that we used in the previous videos. So here I have the file, and now it's stored in the df_laptops data frame. So here's the data frame. And now before filtering a data frame based on 2 or more conditions, let's make a recap of how to filter a data frame based on a single condition. So here in the previous video, we learned how to find, for example, Apple laptops. So we only compare the company series with the Apple string. So here we use the double equal sign to compare these two. So we run this and we got these true or false values. And the same goes for laptops that cost more than 2,000 euros. So we compare this one with the 2,000 number, and in this case we use this sign, and we compare this series with this number. So I run this one, and here I got the results true or false in this array. So now, what if we want to get Apple laptops that cost more than 2,000 euros? So condition 1 and condition 2 together. So in this case, we have to create a multiple condition, and we have to use either the AND or the OR operators. So here, this is the AND and this is the OR operators. So here, let's do this. Let's find Apple laptops that cost more than 2,000 euros. So to do this, first, I'm going to copy the single condition that finds Apple laptops. So I copy this one. Now I paste it here. And now let's write the second condition that finds laptops that cost more than 2,000 euros. So I copy this and now I paste it here. So now we have condition number 1 and condition number 2. So now to filter a data frame based on multiple conditions, first we have to separate this condition 1 and condition 2 with the parentheses. So here I write parentheses, and inside parentheses is my first condition. And I do the same for the second condition. So I write parentheses, and inside this is my second condition. Now we have to use either the AND or the OR operators. And here we have to find Apple laptops that cost more than 2,000 euros. So this has to be Apple laptops and the cost has to be more than 2,000 euros. So we have to use the AND operator. So I write the logical operator and this is the AND. And now I execute this. So here, before I execute, I'm saying first condition and second condition. So here we have to write the parentheses as we did, and then the logical operator in the middle as we did. So now I run this one, and here we can see the results. So here is an array with true or false values. And now to filter the data frame, we have to copy this condition, these multiple conditions, and we paste it here. So we're going to filter the data frame based on this multiple condition. So first we write the name of the data frame, df_laptops, followed by square brackets, and inside square brackets we write the multiple condition. So I paste it here, and now we can run this to see the results. And here I got an error because I didn't write laptops correctly. I need to add the P, and now I run again, and now everything is fine. So here I have the data frame that is the result of this code, and let's verify if it's correct. So here in the company column, we're supposed to get Apple. So here let's verify company. It says Apple, Apple, and only Apple. So here this first condition was successfully evaluated. So now the second condition says that the price should be greater than 2,000. So let's check this price underscore euros column. And now we can see that all the values are greater than 2,000 euros. So we successfully built this multiple condition and filtered this data frame. So now before we continue with the OR operator, you should know that in Python, there is this AND and OR keywords. So here, those are logical operators, but in Pandas, we have special operators. So instead of writing AND, in Pandas, we use this sign that we used in this example. And instead of writing OR, in Pandas, we use this sign here. So it's just the syntaxes we have to follow in Pandas. So try to memorize them. And now I scroll down and here is the OR operator. So now let's continue and let's find laptops that are Apple or Dell. So in this case, we have Apple or Dell. So now, as you might expect, we have to use the OR operator. So here I have the individual conditions. So first, the first condition is this company array equal to Apple. And the second one is this company array equal to Dell. So now I'm going to create the multiple condition based on this simple condition. So here I'm going to write the first one, then write the parentheses, now the second one, so now parentheses. So here I have condition number 1 and condition number 2 grouped, and now I have to add the operator. So here is the OR operator because we want either Apple laptops or Dell laptops. So here I run and we built this multiple condition. So now let's filter the data frame based on these multiple conditions. So let's copy this code. And now I'm gonna paste it here. And we have to follow the same syntax to filter a data frame. So we write laptops, then open square brackets, and inside we put the multiple conditions. So now I run this one, and here I got the result. So now let's verify quickly. The company column should have either Apple or Dell. So let's check. Here is the company column, and here we see Apple, and here Dell. Well, the data frame is a bit longer, so it says Apple, and then we cannot see what's in the middle, but then it says Dell, and then Dell, and yeah, only Dell. So apparently this column only has Apple and Dell, but let's verify this by using the value counts method. So I write value counts. Now I write the name of the column, and now I run this one. And as we can see, there are 297 Dell laptops and 21 Apple laptops. So yeah, we successfully filter this data frame based on 2 or more conditions. Okay, finally, let's challenge ourselves with this last example. So in this case, we have to find laptops from Apple or Dell that cost over 2,000 euros. So I have here each condition separated, and the first one, it says equal to Apple, then equal to Dell, and then the price greater than 2,000 euros. So here we have all the simple conditions. So now we have to create a multiple condition based on this one. So based on these 3 simple conditions. So first, we're gonna write the code that corresponds to Apple or Dell. So here, first we select the first condition, then the second one, and we write the parentheses to group the conditions. So here, parentheses. And now here, between these 2 conditions, I write the OR operator. So here, it's OR because it's either Apple or Dell. And then it says that it should cost over 2,000 euros. So here, I copy the third condition and paste it here. And now I add parentheses. And now, since it should cost over 2,000 euros, the operator we need is AND, because the laptops have to cost over 2,000 euros. So now I wrote here this AND operator, and now this is almost finished. But if we leave it as it is, we could get some unexpected behavior, because Python could group these conditions in an undesired way. So here we have to give clear instructions. So to do that, we have to add parentheses. So here we want this multiple condition I'm selecting right now to be evaluated first. So if we want it to be evaluated first, we have to add parentheses to group this first multiple condition. So with this parentheses that I added here, we're telling Python to evaluate this first multiple condition. And in this way, we're giving Python clear instructions of what we want to accomplish. So now a little recap. This first multiple condition gives laptops from Apple or Dell. And now we're grouping here with these parentheses. So this one is going to be evaluated first. And then this third condition gives laptops that cost over 2,000 euros. So after evaluating this first multiple condition, we're going to get laptops that cost over 2,000 euros. So now hopefully that's clear to you. Now I'm going to copy this and I'm going to filter the data frame based on that condition. So here I write the name of the data frame. Then I open square brackets and inside I paste the code we wrote before. So here's the code. And now I'm going to run this one. So here I press Ctrl Enter and now we can see the data frame. So now let's quickly verify the results. So here the company column should have only Apple or Dell. So here in company says Apple and Apple and then Dell, and then Apple and only Apple and Dell. So that's correct. And now then we have to verify if the price column is over 2,000 euros. And here in the price underscore euros column, we can see that all the prices are over 2,000 euros. So here the first one is over 2,000 and the second one and the third one and all of them. So we successfully built this multiple condition and we filter this data frame based on 2 or more conditions. And that's it. That's how you filter a data frame based on 2 or more conditions in Pandas. Welcome back. In this video, we're going to create a conditional column from more than 2 choices using the select method. So as usual, we're going to import Pandas and read the CSV file laptop underscore price that we've been using in this course. And now I'm gonna create a conditional column from more than 2 choices. So this is similar to a previous lecture where we created a conditional column from only 2 choices using the where method. But in that lecture, we had only 2 choices that were cheap and expensive. But in this case, we're gonna have more choices like affordable, expensive and too expensive. So when you have more than 2 choices, you have to use the select method. And I'm gonna teach you how to do it in this video. So first we import NumPy as NP. So I run this one. And now to create an array based on multiple choices, we have to create first 2 variables. First, the condition variable, which is this one. And this is a list. So here I open with square brackets and inside we're going to create a condition. And the second one is the values. So here I write values and this one is also list. So let's start with the values. Here we introduce all the values that we're going to assign based on the condition that we're going to create. So in this case, we have 4 values as I mentioned before. So in this case, the first one is too expensive. The second one is expensive. The third one is going to be affordable. And the last one, cheap. So these are my 4 categories. And now I'm going to create a condition for each of them. So here I write the first condition and I have to write the name of the data frame, df underscore laptops. Now square brackets open quotes, and here we'll use the price column, which is this one, the last one, price underscore euros. So we use price because we're gonna decide whether a laptop is too expensive, affordable, or cheap based on the price. So let's say that if the laptop costs more than 3,000 euros, this is gonna be too expensive. So the first one will correspond to the first element in the values list. So we continue with the second condition, and now I copy this so it's much easier. And here we're gonna create the condition for the expensive value. And let's say that if a laptop costs more than 2,000 and is less than 3,000, less or equal to 3,000, then it's expensive. So here I have two conditions. This one is the first and this one is the second. So as you might remember, we have to separate both of them with parentheses. So here I write parentheses, and now I write here parentheses. And to create this range, because the expensive value is a range between 2,000 euros and 3,000 euros, we have to introduce here an operator. In this case, we need the AND operator because we want it to be greater than 2,000 and less than 3,000, so at the same time. So now I write AND. So now we have this range. So this one corresponds to expensive. Now let's create the third one. So I add comma, then press enter. And now I'm gonna copy this one so I can create the third range much faster. So here now, let's say a laptop is affordable if it costs more than 800 euros, but less or equal to 2,000 euros. So that's the range for the affordable value. And the last one is gonna be cheap, and this is when is the price equal or less than 800 euros. So that's it. We have the conditions and we also have the values. So now I'm going to delete this and I'm going to run this code. And here I got an error because I forgot to include here the comma. So I write comma and now it's ready. So now I press Ctrl Enter and now it's done. So we have the conditions variable and the values variable. So now let's create the new column. So first, to create a conditional column with the select method, we have to write np.select, then open parentheses, and here we have to introduce two arguments. The first one is the conditions, in this case my conditions variable, and the second one the values you want to assign. So here I have the values in my values variable. So here I write values. So these are the two arguments we need to insert inside the select method. So now if we run this, we see that we get an array. So this array should be our new column. And here in this array, we see the values of affordable, cheap, and all the values that correspond to the price that are in this price underscore euros column. So now we're gonna create a new column. So I write equal to, and here I write this name of the new column. So here I write the name of the data frame first. So df underscore laptops, open square brackets, and here inside quotes, I'm gonna write the name of my new column. So it's gonna be price underscore tiers, and here it's ready. So now I run this, so I have my new column created. So now I'm gonna show it here so you can see it much better. I go to the last column and it's right here. So it's my price underscore tiers column, and as you can see here, we see the values affordable, cheap, expensive, and so on. So let's check if the values were assigned correctly. So here, let's check the first one. and its price is 1,300 euros. So this one is between 800 and 2,000 euros. So the third range that we created here. And the third corresponds to the affordable. So let's verify here. And yeah, it says affordable. Let's do it one more time. So in this case, with this one, it says 2,500. So let's check here. 2,500 belongs to the second range because it's greater than 2,000 and less than 3,000. So the second range corresponds to this second value, expensive. So here it says expensive. Okay, so we successfully created a conditional column from more than 2 choices using the select method. So now let's count the elements inside this price underscore tiers column. So I'm going to do it right here, and I write the name of the data frame. So df underscore laptops, open square brackets, and here I paste the name of the column. And to count this series or this column, we have to use the value counts method. So I write value counts, parentheses, I run this one. And by the way, you can either put this inside parentheses or put it here as I did before. It has the same effect. And now we can see that the majority of laptops are considered affordable. And that's it. Now let's do an exercise so you can understand much better what we learned so far. Okay, this exercise is similar to the one you solved before in the where method, but in this case, we're going to use the select method to create 4 categories. So in this case, we're going to create 4 categories based on the screen size. So we're going to use the inches column that is right here, and we're going to get 4 categories. And here we have the 4 ranges that we have to follow to solve this exercise. And after this, you have to create a condition and values variables. So once you have all of this, you set it to a new column as we did in this video. Then you show the data frame and you count the values inside this new column. Okay, now you can pause the video to try to solve this exercise yourself, and then you can continue watching to see my solution. Alright, let's start by creating the conditions variable. So I write conditions equal to square brackets here. And now here is going to be the conditions that we're going to create. Now also the values list. And here let's write the elements. So the first one is too big. And here I write too big. The second one is only big. The third one is small. So I copy and paste it. Then we have too small. So I paste this one and write too small. So here we have the 4 values. And now let's write the conditions. So here I write first df underscore laptops, which is the name of the data frame. And inside we write the name of the column we want to evaluate. In this case is here and is inches. So now I scroll down and paste it here. So I paste it, and now I'm going to compare this with 16. So if this is greater than 16, it's going to be considered too big. Now I'm going to write the second one. So here I copy, and now, I paste it here. Now, if this one is greater than 14, but less than 16, then it's going to be big. So I write this one here. So less or equal to 16, and I write it here. Now we write parentheses to separate both conditions. So here, now the AND operator, and now we have it here. It's ready. So now I copy and paste this one, and now I delete this blank space, and now I press this tab. So now this one is greater than 12 and less or equal to 14. And the last one should be less than 12. So I write this, now 12, less or equal to 12. So here I delete this one, and now it's ready. So I have the conditions and I have the values here. So now I run this and it's ready. So now we create this new column. So we write np dot select, and the first argument is the conditions variable here, and the second one is the values. And now I run this one and we have this array. So now let's create our new column, which is going to be named screen size. So df underscore laptops, now open square brackets, and I write screen underscore size. So I assign this to this new column, and now I show the data frame. So here I paste it, and now I run this one, and let's check the last column, and it's here. So I have my new column screen size, and now let's count the number of elements inside this new column. So I'm gonna use here the value counts method. So I write df underscore laptops, now square brackets, and I write the name of this new column, which is screen underscore size. And then I write the name of the method, value underscore counts, open parentheses, control enter. And now we have that the majority of laptops are considered big. And that's it. I hope you successfully solved this exercise. Alright, in this video, we're gonna learn how the isIn method works in pandas. We're gonna start by importing pandas and reading the CSV file we've been working with in this course. So we have here the laptop price CSV file, and now it's here in the df underscore laptops data frame. And here our first task is to select Apple or HP laptops. Before we did this task with another methods, but now we're gonna do it with the isIn method. So first we start writing the name of the data frame, so df underscore laptops, and then we write the name of the column we want to apply this filter. And in this case is the company column, because this one has values like Apple, HP, and so on. Then we have to use the isIn method, and we only have to write dot isIn, then parentheses, and here we have to introduce data in form of list. So here, if we want to select Apple and HP, we have to open the square brackets to start a list. So here I open square brackets, and then the first element should be Apple. So I write Apple, and the second one HP. So now what we're saying here is select the Apple and HP element from the company column or company series. So we're gonna filter out all the elements that are not Apple or HP. And now let's run this code. So I press Control Enter, and as you can see here, I got a series with true and false values, and here it made a comparison between this Apple and HP with this company column. So here, for example, the first 3 rows, we have here the data Apple, Apple, and HP. And here we're saying look for Apple and HP in the company column. So the first 3 rows will be true. So here we have true, true, and true. And basically that's how the isIn method works. And now let's filter the data frame based on this condition that we created. So here we have to write first the name of the data frame. So I write df underscore laptops, and now I open square brackets, and as usual here inside square brackets we have to introduce the filter or condition. So here I copy, and now I paste the code we wrote before. So here I have the filter or condition. So now we're gonna filter this data frame. So now I press Control Enter, and as you can see here, the company column only has Apple or HP data. So here it says Apple, Apple, HP, and so on. So now let's verify if this column only has Apple and HP. So we're gonna use the value counts method. I write value underscore counts. Then inside parentheses, I write the name of the column. So I write company. Now I press Control Enter. And here we got that there are only HP and Apple in the company column. So great, we successfully filter our first column. Now let's continue with multiple filtering. And now our task is to find notebooks or ultrabooks from Apple or HP. Here we have two conditions. The first one is notebooks or ultrabooks, and the second one is from Apple or HP. So here we have to use the operators as we did in previous videos to mix the condition 1 and condition 2. Now we're going to write the code for each condition. So let's start with condition 1. So I write filter 1 and equal to, and now I write the code. So here it says find notebooks or ultrabooks. This type of data is inside the type name column. So here we have the type name column and it says ultrabook or notebook. So now we're gonna filter that column. So we write the name of the data frame, df_laptops. Now I write the name of that column. Let me copy it here. So I copy this one and I paste it here. And now we use the is_in method. So we write is_in parentheses, square brackets, and inside we write the elements we want to get. So here, notebooks. Actually, I'm gonna copy it from this one because it's written in a different way with capital letters here. So notebook, and the second one is ultrabook. So here, notebook and ultrabook. And here we're selecting notebooks and ultrabooks from the type name column. And that's the first filter. Now the second filter is from Apple or HP. And actually, we already built this filter or condition. So this one is here. Here it says company and is in Apple or HP. So here we copy this one. And now I'm going to create a new filter. This is going to be filter 2 equal to, and here the code that we created before. So now we have filter 1 and filter 2. And what we have to do now is to link filter 1 with filter 2 with an operator, a logical operator. So we have to choose between the OR operator and the AND operator. So here in this example, we should use the AND operator because here we have to find notebooks or ultrabooks that are from Apple or HP. So here we have to satisfy both conditions. So we write here filter 1 and then filter 2, and we write the AND operator in the middle. So we have filter 1 and filter 2. And here I forget to run this code first. So I run this code and now I'm going to delete this one. And now I run and we got this result here, this series. So now to filter the data frame, first we write the name of the data frame and we open square brackets. And now we run this and we get here a data frame that is supposed to have the values of Apple and HP in the company column, and also the values of notebook and ultrabook in the type name column. And you can verify this by using the value counts method as we did before. And that's it. In this video, we learned how the is_in method works in pandas. Alright, in this video, we're gonna learn how to find duplicate rows with the duplicated method. So here we start by importing pandas and reading the CSV file laptop_price. So here we have the data frame, and the column that we're going to use for our first example is this laptop_ID. So as you might know, IDs are unique, so we shouldn't have any duplicate ID in this data frame. So here, let's see if this column has duplicated values. So we're going to use the duplicated method, and first we're going to find duplicates in one column or series, and the series is going to be this laptop_ID. So here first I copy the name of the data frame, which is df_laptops, and then we write the method that is duplicated. So I write duplicated, open parentheses, and now we only have to write the column. So here I copy and paste the name of the column. And that's it. We only need this. So now we run this code and we got here a series with true or false values. So here we can filter the data frame based on this condition. So here, let's do this. I write here first the name of the data frame, which is df_laptops, then open square brackets. And as we did in previous videos, we have to introduce this condition or this series inside these square brackets. So here we paste it, and now we have this filter. So with this code, we're gonna see if there is a duplicate element or duplicate value inside the laptop_ID column. So now let's find out. I run this one, and now we got this data frame, and we only see the names of the columns, and there is no data. So this means that this laptop_ID column doesn't have any duplicated elements, because if there was any duplicated element, we will see it here in this data frame, but there isn't any duplicated element. Great. Now let's find duplicates in 2 or more columns. So here we only found duplicates in a single column, but now let's find duplicates in 2 or more columns. So now to do this, we're gonna find duplicates inside the columns product, type name, and inches. So to do that, we write the name of the data frame. So df_laptops. Then we write .duplicated. Then we open parentheses, and inside we write the columns that we want to analyze. So here is these 3 columns: product, type name, and inches. So I'm gonna copy this, and now I paste it here, and now I'm gonna write the quote. So here, comma, quotes, and now comma here, quotes, now comma, and that's it. So now I have these 3 columns, and here what we're doing is to find rows that have duplicated elements inside these 3 columns at the same time. So now let's run to explain you this much better. So I run here, and we got this series with true and false values. So now let's make the filter. So we write the name of the data frame. So here is df_laptops. Now we open square brackets, and we introduce this series or condition or filter, call it as you want. So now I paste it here. Now we press Ctrl Enter to run this one, and we got the data frame with the filter. And as you can see here, we got some duplicated elements. So here, for example, we got this first row that has this in product has MacBook Pro, then Ultrabook in type name, and 13.3 in inches. And this one is exactly the same to this one. It has the same values. So now to see this much better, I'm gonna sort this data frame, but first I'm gonna put this inside a variable so you can see it much better. So here I'm gonna create a variable named duplicated equal to this. I run this. Now I copy the new variable, and now I'm gonna sort this data frame so you can see much better the duplicated elements. So now I'm using the sort_values method that we learned in this course. And now I open square brackets, and here I'm going to specify the columns that I want to sort by. So first I want to sort by the product column, and then by the type name column. So here I write type name and product. Now I run this one, and here we got this data frame with duplicated values, but now sorted by product and type name. So now we can clearly see the duplicated values. For example, this one that starts with 15-AC, the notebook 15.6, and is exactly the same as the second one here. So both have the same values, and the same goes for this one here with this one, the same values, and also this one has the same values. And that's how you find duplicates in 2 or more columns. Here, one little detail I almost forget is this keep argument that is set to first by default. So here, this duplicated method has this keep argument. So by default, the duplicated method will only keep the first duplicated element that is listed in a column. And we're gonna see this keep argument in more detail in the following example. Okay, in this second example, our task is to find the cheapest and most expensive laptop of each company using the sort values method and duplicated method. And here I'm going to explain you much better how the keep argument works. So we're going to start by sorting the data frame. So here we write the name of the data frame, df_laptops. Then we use the sort values method. So we write sort values, parentheses, square brackets, and then the columns we want to sort by. So company, the first one, and the second one is, in this case, the price. So the name of the column is price_euros. Here I'm sorting by the price of the laptop because we want to find the cheapest and most expensive laptop. And this is going to make more sense when we add the keep argument in the duplicated method later. So now I'm going to override the data frame df_laptops here. So I write df_laptops equal to this data frame sorted by company and price. So now I'm going to show you the new data frame. So here is the data frame, and now it's sorted by company and also by the price. So the cheapest laptop is first and the most expensive laptop is at the end. Keep that in mind because I'm going to use that concept to explain you much better how the keep argument works in the duplicate method later. So now let's continue here, and now let's check all the values in the company column. So here I'm going to use the value counts method. So I'm going to write df_laptops, and now I write value_counts, now parentheses, and here I write the name of the column I want to evaluate, so company. So now I run this, and here we can see the elements inside this column, and we can see that all the companies have at least two duplicated values. For example, here Dell has 297, and if we scroll down we can see that even Huawei has two duplicated values. So we can say that all the values inside the company column are duplicated. Okay, now let's continue this, and now let's find the duplicated values inside this company column. So now we write the name of the data frame, df_laptops, then that duplicated. Now I open parentheses, and now I indicate the column I want to evaluate. So in this case, company. So now I run this and we get this series. And as you might remember, this duplicated method has by default the keep argument, which is set to first. This means that only the first duplicated value is gonna remain, while the others will be removed. So here, just to remind you that, I'm gonna add the keep argument and I'm gonna set it to first. I don't need to do that because the keep argument has this first value by default, but I'm just writing it so you don't forget about it. So now I'm gonna set this to a new variable, which I'm gonna name duplicated_first. So this is my new variable. Now I run this, and now I have all of this filter inside that duplicated_first variable. So now what I'm going to do is to filter the data frame based on this variable. So I write the name of the data frame, df_laptops, now open square brackets, and now I paste the value of this variable. Now I'm going to run this one to see the data frame filter. So now I got here the result, and here I get the data frame with duplicated values in the company column. So now I want to show the data frame with non-duplicate values in the company column. And to do that, we have to use the not operator. So this one. And what this does is to get the opposite result of this filter. So here this variable gives us the duplicated elements, but if we use the not operator, we're gonna get that non-duplicated elements in this company column. So now let's check this out. So I'm gonna run this one, and as you can see here, we got in the company column different values. So here first says Acer, then Apple, then Asus, and as you can see, none of these values are repeated, so none of them are duplicated. All of them are different. So now to check this much better, I'm going to select two columns. The first one is going to be company, and the second one is going to be the price. So here I choose the price because our task is to find the cheapest and most expensive laptops. So here I select these two columns, and now we have this more compact data frame. And here, as you can see here, all the elements inside the company column are different. And also these are the lowest laptop prices per company. So all of these laptops are the cheapest in each company. And we didn't get this by accident. We got this because we used the source values method, and also we set this first value to the keep argument inside the duplicated method. Here I'm going to scroll up a little bit to explain you much better what we did. Here, when we sorted by the prices and by the companies, what we did here is to show the cheapest laptops first. So the cheapest were first and the most expensive were in the last position. So here, then when we set here keep equal to first, it means that only the first duplicate value is going to remain in the data frame. That is, only the laptop with the cheapest price will remain in the data frame. And that's why all of these values inside this data frame represent laptops with the cheapest price per company. So for example, here, the cheapest Apple laptop costs 898 euros. And that's it. Now we can even check if this data frame actually have duplicated values or not. So here we only have to use the value counts method. This is optional. You don't have to do this, but I'm going to show you that this one doesn't have any duplicated values. So I run this one. And now, as you can see, all of the elements inside the company column only have one value. So here, Acer has one, Lenovo has one, and so on. So there isn't any duplicated values here. Okay, that's how the keep argument works when it's set to first. Now let's check how it works when keep is set to last. So here I'm going to copy the same code we use here because it's actually the same. We only have to modify the argument keep. So here is the same code. Now I'm going to change it here. Instead of first, I'm going to write last. Now I'm going to set this equal to a variable that I'm going to name duplicated underscore last. So this is my new variable. Now I run this, and now let's show a data frame with non-duplicated values in the company column. And in this case, since we're using keep equal to last, we're supposed to get the most expensive laptop per company, because first we sorted the data frame ascending. So first were the laptops with the cheapest value or cheapest price, and at the end we got the laptops with the most expensive price. And if we say here keep equal to last, this means that we're gonna get only the last duplicated value. So now let's check if this is true. Now I'm going to filter this by writing df underscore laptops. So here, so now let's verify if this is true. So I write here df underscore laptops. Now I open brackets, and here I write this duplicated underscore last to make the filter. And now I have to write this not operator. So here I'm saying non-duplicate values. So here I'm going to get non-duplicate values. So I press Ctrl Enter, and now we got this data frame. And now let's select two columns to make this data frame smaller. So first the company column and also the price column. So it's price underscore euros. So I write it here. Now I run this, and now we got this data frame. And all the values inside the company column are unique, so there isn't any duplicated values. And also here we got the most expensive laptop per company. So for example, the most expensive Apple laptop costs 2,858 euros. And we could get this data frame by setting the keep argument equal to last, and also by using the sort underscore values method. Alright, now let's see how the keep argument works when it's set to false. So now I'm going to copy this code and I'm gonna set it here. So instead of last, here I write false. And I'm gonna change the name of the variable. So in this case, it's gonna be duplicated underscore false. Now I run this code and I scroll down here and I'm gonna make the filter here. So I write df underscore laptops, then open square brackets, and inside I write the name of the variable that we created here. So it's duplicated underscore false. So now I write this, and now to get that non-duplicated values, we use the not operator. So we write here the not operator, which is this one. And now we press Ctrl Enter. And as you can see here, this data frame is empty. And this happens because we set the keep argument equal to false. And this means that we're not going to keep neither the first duplicated value nor the last one. And as you might remember, the company column only has duplicated values. So here I'm gonna write the code so you can remember in case you forget about this. So I write df underscore laptops, then value counts, and now I write the name of the column company and press Ctrl Enter. So as you can see here, all the values inside the company column are repeated at least twice. So for example, Huawei is repeated at least twice. So all of them at least have one duplicated value. This is why we got this empty data frame, because all the values inside the company column are duplicated. And that's it. In this video, we learned how to find duplicate rows with the duplicated method. Okay, in this video, we're gonna learn how to drop duplicate elements with the drop duplicates method. So here I have already pandas imported and also the CSV file that we've been working with so far. And here I have the data frame. Now let's see how the drop duplicates method works. Okay, the drop duplicates method helps us remove duplicated elements in one or more columns. So this is similar to the not operator we seen before when we use the not operator to get the non-duplicated values. And this can also be accomplished with the drop duplicates method. So now let's have a look. And first, to use this method, we have to write the name of the data frame as usual. And here I write df underscore laptops, and now that drop underscore duplicates. Now I write parentheses, and now I open square brackets, and inside I write the name of the column I want to evaluate. So here the name is going to be company. So here we're going to remove duplicate elements inside the company column. So I run this, and now we shouldn't get any duplicated element in the company column. So to verify this, I'm going to select only the company and price underscore euros column. So here I run, and now we can easily see all the elements. So we can see that in the company column, we don't get any repeated value. So Apple, HP, Acer, and so on. Well, none of them are repeated. And actually we can verify this with the value counts method. So here that value counts, and here inside parentheses we write company. So we run this, and all of them only have one element, so no duplicated elements. So now I'm gonna get back the data frame here. And now our task is gonna be to find the cheapest and most expensive laptops. So here in the drop duplicates method, we also have the keep argument. So let's see how it works. So first we have to sort the data frame ascending by company and price. And as you might remember, this helps us put the cheapest laptops first and the most expensive laptops at the end. So here we write df_laptops that sort values, and inside parentheses we write the name of the columns we want to sort this data frame by. So we write company inside quotes, and then we write the name of the other column, which is price_euros, and it's here. So we run this, and now this data frame is sorted. So let's overwrite the values inside this data frame. So here I run, and now the df_laptops data frame is sorted. So now we can get the cheapest laptops by setting keep equal to first in the drop duplicates method. So here we write df_laptops, then .drop_duplicates, and now we write the name of the column, which is company, and we add the keep argument. So here keep equal to first. Actually, we don't need to add this keep equal to first because this is set by default, but I added here so you don't forget about it. So now let's run this one. So let's select only the columns we're interested in. So here I select the company and price euros. So I write square brackets and then paste this. So now I run, and here we can see all the laptops with the cheapest values per company. And now if we want to find the most expensive laptops per company, we only have to set this keep argument equal to last. So here I copy, and now I'm gonna paste it here. So I paste it, and now I write keep equal to last. So now I run this one, and we see here all the most expensive laptops per company. And this is the same result that we got when we used the not operator with the duplicated values in the previous video. All right, now I want to show you two more arguments. And the first one is the in place argument. I think you're quite familiar with this one. So this one saves all the changes we made to the original data frame. So when this is equal to true, we're saying that all the changes that we're making to this df_laptops data frame are going to be saved. However, when this is set to false, which is the value by default, we're saying just to return a copy. So now we want to save the changes we made. So I'm going to set this equal to true. And the other argument I want to show you is the ignore_index. And this one by default is equal to false, but we're going to set it equal to true. And this is going to ignore all the original indexes that the data frame had. So for example, here, the original index of this row is 1189. But if we set ignore index equal to true, this is going to be 0. And the second one is going to be 1, and then 2, 3, and so on. So now let's run this to try these two new arguments. But first, I'm going to delete this selection I'm making because we're not getting a copy because we set this in place equal to true. But we're only saving the changes we're making. So we're updating this data frame. So here I delete this, and now I only have this. So I run this, and now this data frame should be updated. So now I'm going to show it here. So I write df_laptops. I show it here, and now we have this data frame. And as you can see here, it starts with 0, 1, 2, and so on. And now I'm going to select only the columns we're interested in. So I write company, then comma, and here price_euros. So now let's clearly see what's going on here. Here we got the last duplicated elements, and also we ignored the original indexes. And that's it. Now it's time to solve an exercise to put all these concepts into practice. Alright, in this exercise, our task is to find the biggest and smallest screen size in laptops for each company using the sort values and duplicate methods. And here we have to use also the keep argument so we can get the smallest and biggest screen size. Okay, now you can pause the video and try solving these exercises on your own, and then you can continue watching the video to see my solution. Okay, to solve this exercise, let's start by sorting the data frame. So I write df_laptops, now sort values, and here I'm going to write the name of the columns I want to sort by. So first is the company column, and then is the inches column because we want to analyze the screen size. So here I sort by these two columns, and now I'm gonna overwrite the values inside this original data frame. So now I run this, and now in our data frame, the small laptops should be placed first and the biggest laptops should be placed at the end. So now let's choose the smallest laptops per company, setting the keep argument equal to first. So here I write the name of the data frame, then drop underscore duplicates. So now I open parentheses, and here I write the name of the column I want to analyze. So in this case is company. Now I add the name of the argument, keep, equal to first. And here I run this code, and in this data frame we shouldn't have any duplicated element in the company column. And to clearly see the laptops with smallest screen sizes per company, we only select these two columns. So here I'm gonna copy it, and now I open square brackets and paste this. So now I run this, but before we see the results, let's first read the CSV file so we make sure that we have the original data frame here. So here I have the code that reads the laptop underscore price CSV. So here I'm gonna read it again, and we do this because we made some changes in the previous examples, so we want to start from scratch. And here I read this CSV file. So this is the original data frame, and now let's run this again, and also this one. So now let's see the smallest laptops, and here we got the smallest laptops. And in case we want to get the laptops with the biggest screens, we have to copy this and only modify the keep argument. So here I'm gonna paste it below, and now here I modify this, and now it's last. Now I run this, and here we got the laptops with the biggest screen. So for example, the Apple laptop with the biggest screen is 15 inches. And here above, we got that the Apple laptop with the smallest screen is 11 inches. And that's it. I hope you successfully solved this exercise. Alright, in this video, we're gonna learn how to get and count unique values using the unique and end unique methods. So first, we're gonna start by importing pandas as PD and reading the laptop underscore price CSV file. And now we have this data frame. And now we're gonna count some unique values of some columns in this data frame. So here, I'm gonna explain you first what the unique method does. So this one returns unique values of series object, and the uniques are returned in order of appearance. So here, let's get unique elements in the company column. So to do that, first we have to write the name of the data frame, in this case df underscore laptops, then write square brackets, then the name of the column, in this case company, and this is the syntax of the series. And now we have to use the unique method. So we write that unique, and that's it. It's as simple as that. So now I run this one, and here we get an array, and this array contains unique elements inside the company column. And now let's see another example, but now with the inches column. So as you might remember, this inches column represents the screen size. So now let's do this. So we write again the name of the data frame, followed by square brackets. Now the column is inches, and we write that unique. We open parentheses, and now we run this. And here we get an array, and the array has all the screen sizes. So 13.3, 15.6, and so on. Now we can get how many unique elements are in a column. We only have to use the len function. So here I write len. Now I open parentheses, and inside I write this. So this is the code we created before. So now if we run this, we can get the length of unique elements inside the inches column. So here we have 18 unique values inside the inches column. And now if we write company instead of inches, we're gonna get how many unique elements are in the company column. And here we have 19. So there are 19 unique values inside the company column. And that's it for the unique method. Now let's check how the endUnique method works. And this one returns number of unique elements in an object, excluding null values by default. So this is basically the same as the len function. But here we have a method in pandas. So let's use this endUnique method. So we write first the name of the data frame, followed by square brackets, and now the name of the column, so company. First, we're gonna know how many unique elements are in the company column. So first, we have here the company series, and now we write that and unique. Now we add parentheses and we run this, and we got 19. So there are 19 unique elements in the company column. And this result is the same as the one we got here with the len function. Now let's get the number of unique elements in the inches column. So we copy this code and I paste it here, and now I just have to write here inches. So now I run this, and here we got 18 unique elements in the inches column. And it's the same we got before using the len function. And that's it. In this video, we learned how to get and count unique values using the unique and endUnique methods. Welcome back. In this video, we're going to learn the difference of selecting data with the methods lock and iLock. In pandas, we can select data by using the methods lock and iLock. Both have some similarities, but also have some differences. And in both methods, to get the data we want, we only need to pass the indexes and the columns. Okay, before showing you how these two methods work with code, we're going to learn some core concepts, and also we're going to see some examples. So first, the lock method. So the lock method is label based. So we have to specify rows and columns based on their index and column labels. So this means that we have to write the name of the index or the name of the column in order to get the data we want with the lock method. So our first argument will be the name of the index, and our second argument will be the name of the column. And now let's check the iLock method, and this method is integer position based. So we have to specify rows and columns by their integer position values. And this one is a zero-based integer position, which means that it always starts with 0. So the main difference between the lock method and the iLock method is that with the lock method, we only need the column and index labels. But with the iLock method, we need to specify the integer position values. So we have to locate a data inside a data frame and then see in which position is the row or the index and in which position is the column. Okay, now to understand this much better, let's see an example. So here we have this data frame that I named df, and this data frame has 3 columns, foo, bar, and baz, and also has 6 indexes. And the first index is 0 and the last one is 5. So here, this 0, 1, 2, 3, 4, and 5 that is on the left, those are indexes. And those are the index labels or the index names. But here on the right, we can see the index position of each of them. So the first element has a 0 index position, and the last element has a 5 index position. Here I wrote the name of the index using letters and not numbers in purpose because I wanted to show the difference between the index label and the index position. The index label is the actual name you see in the index. It can be words or numbers, but the index position can be only numbers and always start with 0. Okay, now let's see some differences between the log and the ilog methods. So in the first one, you can introduce the label or the name of the index or the column, but in the second one, you only can introduce the position of the index or the position of the column. So here, for example, if you want to select an element with a value, you will see some differences between these two methods. So with the log method, you have to write the name of the data frame, df, followed by .log with square brackets. And inside these square brackets, you have to write the name of this index. In this case, I want to get the value of the index 0, so this one. So that's why I specify that index label. So here I wrote df.log and then 0 inside square brackets. But in the second method, so the ilog method, we have to write df.ilog and inside square brackets, we write the position of this index. So in this case, the position is position 0, so the number. So here we wrote the number. Okay, now let's continue. And to select elements with a list is similar. So we write df.log, we open square brackets, and inside we write the list. So in this case, the elements will be the index labels. So in this case, 0 and 2. And for the ilog method, we write .ilog and then square brackets, and inside square brackets, we write the list. But now the list has the index position. So 0 and 2 in numbers. Okay, now to select elements with a slicing, we have to write df.log, and inside square brackets, we have to write the syntax start, stop. So in this case, the start element is 0. Then we have the colon, and then the stop element is 2. So these two elements are my start and stop. And with the ilog method, we write df.ilog, and inside square brackets, we write the position of the index. In this case, the number 0 and the number 2. But here, there is a big difference between these two methods. So in the log method, the start and the stop element are included in the slicing. However, in the ilog method, the start element is included, so 0 is included in this slicing, but the stop element is not included, so is excluded from the slicing. This means that we're going to get only the data that belongs to the index 0 and index 1 using the ilog method. However, we're going to get the data from index 0, 1, and 2 if we use the log method, because the start and stop elements are included in the slicing. So this is a big difference that you have to keep in mind when you use either the log or the ilog method. So now to finish this video, let's see how the following lectures will work. So as you've seen in this video, the log and the ilog methods are quite similar. The big difference is between the name label that the log method uses and the index position that the ilog method requires. In the log method lecture, we're going to have an average lecture, which means that I'm going to teach you how this method works with examples, and we're going to do it together. However, when we get to the ilog method lecture, we're going to do something different. So this lecture is going to be an exercise for you. So the examples we're going to see in the log method and the ilog method are going to be the same. So you have kind of translate the code we use in the log method to select elements with the ilog method. After you try to solve these exercises on your own, we're gonna check my solution and compare the results. And that's it. In this video, we learned the differences between the log method and the ilog method. Okay, in this video, we're gonna have a look at the dataset we're gonna work with in this section. So first, we're gonna import pandas as PD as usual. So I run this first line of code, and then we're gonna read the CSV file that we'll use in this section. So to do that, we use the read_CSV method. So I write pd.read_CSV, and here I open parentheses, and now I open these quotes, and now I'm gonna write the name of this CSV file, which is players, and now I'm gonna complete this with tab. So here's the name, players_20.csv. So I'm gonna press Ctrl Enter to see the values, but here I added this S by mistake. I'm gonna delete it, and here I run again, and now everything is fine. So here's the data frame. And now we can see that this data frame contains information about soccer players. And here we can see different information about the players, like the age, the height, the weight, nationality, and so on. Okay, now I'm gonna name this data frame, and I'm gonna set this equal to df. So I write df equal to pd.read_CSV. So I run this, and now I'm gonna show the data frame, and also I'll show you the columns we'll use in the next videos. Okay, now we have the data frame, and the first thing we're gonna do is to set the short underscore name to the index. So this short underscore name is a column that contains the names of these soccer players. And if we set this to the index, now instead of 0, 1, 2, and 3 in the index, we're gonna get the names of the players here. So we can identify the rows easily, and that's gonna help us a lot in the following videos. So here, I'm gonna copy the name of the data frame, but actually I don't need it because it's just df. And here, to set a column as an index, we have to use the set_index method. So we write set_index, we open parentheses, and now we write the name of the column inside quotes. So here is the name of the column. So I copy it, and now I'm gonna paste it here. And if I run this, we can see that the new index is the short underscore name column. So here we can see the names of the players, and now we can easily identify each row because it's not a number, but now a player. Okay, now this set_index method created a copy of this df data frame. And if we want to save the changes and update this data frame, we have to overwrite this data frame. So we can write this df equal to df.set_index, or we can also use the in-place argument. So I write in-place equal to true, and now if I run, we're gonna see that all the changes were saved. So we're supposed to get the data frame with the index short underscore name. So let's have a look. I run this, and here we can see that this index is named short underscore name and contains the names of soccer players. Finally, we're gonna select some columns that we're gonna use in the following videos. So here, if I scroll down, you're gonna see that the data frame has around 100 columns, and those are a lot of columns. So we're gonna select like 7 columns. So here we're gonna use the columns that start with long underscore name until club. So these 7 columns. So right now I'm gonna copy these 7 columns, and now to select these columns, we're gonna use double square brackets. So here, double square brackets, and now I write the name of the columns, or actually I'm gonna paste them, and I have it here. So now I add quotes and also comma to separate each column. And after this, I'm gonna explain you what each column means, so you can understand much better the data set we're working with. So now I only have to add quotes here in the club, and now it's ready. So now I select the columns in here, I run, and you can see that there are only 7 columns. So now let's have a quick look at each column. And here first we have the long name, and this is the full name of the player. So here this is the short name and this is the long name. Then we have the age, then DOB is the date of birth of each player. Then we have the height, and this one is in centimeters, and the weight is in kilograms. Then we have the nationality and the club each player played by the year 2020. And that's it. Now I'm gonna just overwrite the value of this data frame so we can only have these columns. So here I overwrote the value, and now here we have the data frame. Okay, now your task is to check this data frame in detail so you can easily understand the following videos. Okay, in this video, we're gonna learn how to select elements by index label with the log method. And we're gonna start by importing pandas and doing all these things we did in the previous video. So here I have the code that we did in the previous video. And now I'm gonna run these 3 cells. And now here we have the data frame we created in the previous video. So we have the 7 columns we selected, and now we're gonna start by selecting with a single value. So here we're gonna follow this syntax of the log method, which includes the square brackets and then the row label or index label and also the column label. So our first example is to get all data about the player Lionel Messi. So here, to do this, we're gonna write the name of the data frame, which is df, then .log, then open square brackets, as it says here. And now we write the name of the player. So in this case, it's Lionel Messi. And actually, I'm gonna copy the name because it's written in a different way. So I make sure everything is correct. So here, I write or I paste Lionel Messi or L.Messi, and here I run, and we get all the data about this player. So we have his full name, the age, and all this data. So now let's get a particular value of this data that we got. So for example, we can get the height of this player by writing df.log, and now we have to write the index name. So in this case is the name of the player. So I write L.Messi, and then we have to write the column label. So we want the height of this player, and the height is inside this height underscore centimeters column. So here I paste the name of this column, and it's here. So we follow the syntax, and now we have this. So we run this, and as you can see now, we got the value of 170, and that's the height of this player in centimeters. So now let's continue with the next example, and in this case, we have to get the weight of the player Cristiano Ronaldo. So now I'm gonna copy this, and I'm gonna paste it to have it as a reference. So now here in the index, we have to write the name of the player. And by the way, here we set the name of the column short underscore name to this data in purpose so we can use this data as the index, ignore the numbers 0, 1, and so on. So here, this short underscore name help us easily find this data with the log method. So now in this case, we want the name of the index, and in this case is Cristiano Ronaldo. And now I'm gonna copy and I'm gonna paste it here. So here the index name or the row name is Cristiano Ronaldo. And now we want the weight in kilograms. So here I write kg, and now it's ready. So now I run this one, and we can see that the weight of this player is 83 kilograms. Okay, now let's get all rows inside the height column. So far we get here a specific value of this height, and also the weight. But now we want all the rows about this column. So we can do that by using a special symbol or a special sign. So this sign is this colon, and this allows us to select all the elements inside a row or inside a column. So now let's see how it works. First, we write the name of the data frame followed by .log. And now here we want the height in the column. So here we write comma and we write the name of this column. So here height underscore cm. And then here in the index, we want all the rows. So in this case, we write the colon, and this indicates that we're going to get all the elements and all the elements in the index this time. So here we run this, and now as you can see, we got this series, and this series is about the height of the players. So here we have the information about the height of all the players listed here. So for example, Lionel Messi is 170 centimeters, then Neymar is 175, and so on. And now we can use this symbol in the column labels. So I'm going to show you here, and we have to get all the columns that correspond to the index Lionel Messi. So here I write df.log, open square brackets, and here I write the name of the index, which is the name of the player, l.messi. And now we have to write the name of the column. So in this case, we want all the columns. So we need the colon sign, and I write it here, and now it's ready. We run, and we get all the columns that corresponds to the index Lionel Messi. So here we have the data, and this one looks similar to the one we got here that we obtained by writing only the name of Lionel Messi. And yeah, it's the same, but in this case, we use this column that help us get all the columns of this index. Okay, now let's see how to select elements with a list of values. In the previous section, we selected elements with single values, but we can also use lists. So in this case, we want to get all the data about Lionel Messi and Cristiano Ronaldo. So here we have two elements, so we can introduce these two elements inside a list. So now we create a list with square brackets. Now we open here the quotes and we introduce the first element. So in this case, l.messi, and now I write this blank space. And now we write the second element, which is Cristiano Ronaldo. So now I write here, and now we have to put this inside the log method. So here I write df.log, open the square brackets that belongs to this log method. Now we introduce this list. So here I copy and paste it here. And now with this, we're gonna get all these elements inside this list. So I run this, and now we can see this data frame. So now we have the data about Messi and Ronaldo and all these columns here. So that's how you select elements with a list of values. And now let's get the height of Messi and Ronaldo. So in this case, we can create the list and also add a column. So here we got the 7 columns, and we can get or specify one column. So I'm going to show you here, and first I copy this code we created here, and now here is the name of the index. So now we only have to write the name of the column we want. So here we have to write the name of the height column. So here is height underscore cm. So I paste it here, and now instead of getting this data frame with all these columns, we're gonna get only one column. So here I run this, and now we only have the height of these two players. And now let's get the height and the weight of Lionel Messi. So here we have to create a list for the column names. So in this case, we should have a list with 2 column names. So I'm gonna create a list. So I open square brackets and now I write the name of the height column, and it's here, height underscore cm. So I open these quotes, and then the second element is weight underscore kg. So here kg, and now this is my list. So now I write df.log and put this inside this log method. But first I'm going to write the name of the index, which in this case is also the name of the player. And here is l.messy. So I write it here. Now open quotes. And now I add this blank space. And now I can add this list that corresponds to the column names. So it's here. And now if I run this, we get the height and the weight of this player. All right, now let's get the height and weight of Messi and Ronaldo. And this is going to be like a mix of the previous examples. So here I write df.log square brackets, and inside I write first the list of the index names. So in this case, the index are Messi and Ronaldo. So here I have it here from the previous example, and this list has Messi and Ronaldo. So I copy this list and I introduce it here as the index names. So here we have our first list, and then we have to write the column names, and here it's the height and the weight, and here I have it inside a list. So it's height and weight. So copy and paste it, and now we have these two elements, and these are inside the log method. So I run this one, and now we can see that we have this little data frame with the height and weight of Messi and Ronaldo. Okay, now we're gonna learn how to select a range of data with a slice. And here we're gonna use this syntax that it's here, which is start colon, stop colon, step. And as a side note, this is contrary to usual Python slices. So in Python slices, this stop element is excluded. But here in pandas, both the start and stop are included. So this is kind of an exception. So here you just keep in mind that this start and the stop are included. So that said, now let's continue with the first example. Here we have to make a slice in the column labels. So here I'm going to show you the data frame so you get a better idea of what we're going to do here. And I'm going to use this little data frame. So here we're going to make a slice between the columns H and the column club. So I'm going to struct these 2, 4, 6 columns. So I can do that by slicing these columns, and I'm going to show you how to do it here. So here I can use this syntax. So first we write the start element or the start column. In this case, this is going to be the H. Then we add the colon, and then we add the column that is the club. So here I write club, and now we have this syntax: start colon stop. So here H colon club. And now we have to put this inside the log method. So here I write df.log square brackets, and first we introduce the name of the index that we want to select. And this time I have this one created and is a list that has Messi and Ronaldo as elements, and the name of the list is players. So here I write the name of this list, so players. And now we have to write the name of the columns. So here I copy or cut this slicing, and now I paste this slice. So we have this slice from H to club. So now we can run this, and now as you can see we have the slice between H to club. So only the columns between these two columns were selected. And as you can see, the club column is included in this slice. So that's how you make a slice with column labels. And we can also make a slice with index labels, and I'm going to show how to do it here. Okay, in this example, we want to slice index labels that are between the top 1 and the top 10 player. So this dataset sorts the players based on their scores in the FIFA game. So the first player or the first row that is in this dataset is the best player according to this FIFA game. And the 10th player in this data frame is the 10th best player in this game. So here we can get a slice that represents the top 10 players by selecting from index 0 to index 9. But first we have to get which player is in index 0 and which player is in index 9. So here we have to use the index attribute. So I write df.index, and now to get the first 10 elements, we write here the square brackets, and now this colon, and then 10. So this represents the 10 first elements in this index. So here, if I run, you can see all the indexes. And if I write now the square brackets, we're gonna get only the first 10. So here we have the first 10, and we have that the best player in this game is Lionel Messi, and the 10th best player is Mohamed Salah, which is here. So now we can make a slice by writing both Lionel Messi and Mohamed Salah. So the start element will be Messi here, and then the stop element will be m.salah. So I'm gonna write it here. So first is gonna be the first element or the first index, then colon, and then the 10th element. So I write it here, Mohamed Salah. And now what we have to do is put this inside a log method. So here I write df.log, then square brackets, and now we cut this slice, and now I paste it here. So now this is the index or the name of the index, and then we have to write the name of the columns. And I created here a list that is here, and the variable is named columns. So I copy this one, and now I paste it here. So now if I run this, you can see that we get the first 10 players in this data frame. So from Lionel Messi, which is index 0, to Mohamed Salah, which is index 9. And that's how you select a range of data with a slice in the columns or in the index. Finally, let's see how to select elements based on a condition. So in the previous videos, we learned how to make conditions in pandas, and now let's make conditions and also select elements from these conditions. So here we have this condition that says select players with height above 180 centimeters. So to create that condition, we have to write here the name of the data frame. So I write df, which is the name of the data frame, and then open square brackets, and we write the name of the column we want to evaluate. So in this case is the height column. So I copy this one and paste it inside square brackets. Now we have to compare this with the 180 centimeters, and we only write the numbers here to compare it. So here, greater than 180. So here we have this condition, and we have to put that condition inside the log method. So here I cut this and put it here in the first argument. So here is supposed to filter now our index. And now we have to write the name of the columns we want to select. So in this case, the name of the columns are here inside my columns variable. So I copy and paste it here. So now we're selecting elements that satisfy this condition in the index and that belong to these columns inside this columns variable. So I run this, and we can see here in this data frame only players above 180 centimeters. So for example, Lionel Messi is not here because he is 170 centimeters, so he's not here. Okay, now let's select elements based on multiple conditions. So here our task is to select players with height above 180 centimeters, and from Argentina. So here is condition 1, the height, and the second condition is the nationality. So here we write both conditions, and the first one we actually build it here. So here is my first condition, height above 180. So I paste it here. So first condition is done, and now we have to write the second condition. So nationality equal to Argentina. So here I copy this one, and now I write the name of the column, which is nationality, but I want to see how it's written. So it's here, nationality. So I paste it here, and now this has to be equal to the country Argentina. So I write here, and here we have condition 1 and condition 2. So to satisfy both conditions together, write the parentheses here to separate them first, and then to satisfy these two conditions together, we have to write the AND operator. So the AND operator is represented by this symbol, and here we have condition 1 and condition 2. So with this, we're going to satisfy both conditions. And now we only have to insert this multiple condition inside this log method. So I cut this one. Now I paste it here, and this is going to help us select elements based on this condition. So now I only have to write the name of the columns, and here instead of writing the name of the columns one by one, I'm gonna write only the column symbol, which indicates that I want all the elements. So here I wrote this column sign, and now I press Ctrl Enter to execute this code. And here we have players with height above 180 centimeters from Argentina. So as you can see here, we don't have Cristiano Ronaldo anymore because he's from Portugal, but we have other players from Argentina with height above 180 centimeters. And that's it. In this video, we learned different ways to select elements with the log method. Okay, in this video, we're gonna learn how to select elements by index position with the ilog method. So as usual, I imported pandas and ran these 3 first cells to get this data frame that has these 7 columns and this short name column in the index, so it looks like the one we created in the first video. And now we're gonna select elements with a single value, but in this case we're gonna use the ilog method. So all these exercises are the same as the examples we've seen with the log method, so I recommend you to resolve these exercises on your own, and you can pause this video, and after you try it yourself, you can continue watching the video to see my solution. So you can download this Jupyter notebook file that is in the notes of this video to start solving these exercises. Okay, let's start with the first task, and here we have to get the height of Lionel Messi. So we have to write df.ilog and then square brackets, and inside, instead of writing the names of the index or the name of the column, we have to write the position. So here, what we have to do is to write the position of Lionel Messi, and this one is position 0 in the index, because here, as you might remember, Lionel Messi is first here in the first row. So first row, position 0. So here 0, and then the height is the position of the column here. So this is 0, this is 1, this is 2, and height is position number 3. So we write 3, and that's how we do it. So now we run this code and we get the height of Lionel Messi. Then we have to get the weight of Cristiano Ronaldo, and I'm gonna copy this one so we can do this faster. So here, first, the index of Cristiano Ronaldo here is 1. And now the column of the weight, I think, is here. So its height is number 3, so weight is number 4. So here, instead of 3, we write 4. And now we run this, and we get that the weight of Ronaldo is 83 kilograms. Then we have to get all the rows inside the height column, and in this case I'm going to use the colon symbol, and is this one. So this represents all the elements either in the rows or in the column. So here we write df and then dot ilog, then square brackets, and since we want all the rows, we have to introduce this one first as first argument, and we get all the rows. Then here we have to write the position of this height column. So here the position is 3 because we did before in this exercise, so it's 3, and we paste it here. So we paste it and we run now, and we get all the rows inside the height column. Next, we have to get all the columns that correspond to the index Lionel Messi. So we write df.ilog, and then we write the index that corresponds to Messi, which is index 0, and then we write the colon symbol because we want to get all the columns here. So if we write the colon symbol, we're going to get all the elements that are inside the column. So here we press Ctrl Enter, and now we get all the elements or all the columns that correspond to the index Lionel Messi. Okay, now let's select elements with a list of values using the ilog method. So the first task here is to get all data about Messi and Ronaldo. So we use df.ilog, and now we open square brackets, and since we want to get the data of two players at the same time, we have to create here a list. So here is my list, and now I write the index of Messi, which is 0, and then the index of Ronaldo, so 1. Then we have to put this list inside this square brackets. So here we paste it, and now we press Ctrl Enter, and here we have all the data that corresponds to these two players. Next, we have to get the height of Messi and Ronaldo. So we write df.ilog, and here we have to write the indexes that corresponds to Messi and Ronaldo, and here we have it from the previous exercise. So I paste it here, and now we have to write the position of the column height. So in this case is position 0, 1, 2, and 3. So we write 3. Now we press Ctrl Enter, and we get the height of Messi and Ronaldo. Next, we have to get the height and weight of only Lionel Messi. So here, again, df.ilog, and then here we write the index that corresponds to Messi, which is 0, and here the position of height and weight. So height is 3 and weight is 4. Now we press Ctrl Enter, and we get the height and weight of Messi. And finally, we have to get the height and weight of both Messi and Ronaldo. So it's like a mix of the previous exercises. So let's do it here, df.ilog, then square brackets, and we have to introduce first the list that corresponds to Messi and Ronaldo. So here I have this one, so I paste it here. Now the columns that represent the position of height and weight, and it's this one. So we copy, and now we paste it here. Now Control Enter, and we have this little data frame that shows us the height and weight of both Messi and Ronaldo. Alright, now let's select a range of data with a slice. In here, you have to remember that we have to use this syntax start colon stop, and here the start is included but the stop is excluded. So keep that in mind. So here we have to get the slice of the columns that are between age and club. And here we have the index we have to use. So first we translate this players variable. So instead of writing the name of the players, we write the index or the position. So here is 0 and 1. And then we have to write the df ilog as usual. And now we have to write square brackets, and inside we paste the index of the players. So here players, then we have to write the slice that we want to make. So now let's see which position corresponds to the age and the club column. So here I'm gonna show this data frame, and here we have age. So this is 0 and this is 1. And here club is 2, 3, 4, 5, 6. So age is 1 and club is 6. So now we write here, I'm gonna delete this one because we don't need it anymore. And here is 1 and 6. But as you might remember, this last element, the stop element, is excluded. So we have to write this one plus 1. So if we write this, we get 7, and the 7th is gonna be excluded. So we get the number 6. So that's why we do this. So 6 plus 1 is 7. So we get this 1 colon 7, which represents a slice from the age to the club column. So now it's ready. So we run this one and we get this slice from age to club, and we get the index of Messi and Ronaldo. Okay, now let's get a slice of the first indexes. So here first we start translating these columns variables. So instead of writing the names, we write the position. So 1, 2, 3, and 4. So this one, as you might remember, age is position 1, and here the column DOP is next to age, and also height and also weight. So 1, 2, 3, and 4. So it's here. And now we have to write the syntax. So df.ilog, then square brackets. And now what we have to do here is to write the slice that we want. So in this case, we want the first 10 indexes. So we do this because we want to get the top 10 players. So if we want the first 10 elements or the first 10 indexes, we have to write here 0, which is the start element, then colon, and then the stop element, which is in this case 10, because this is excluded and we're gonna get the number 9. So we get from 0 to 9, so the top 10 players. So this is my slice, and now I'm gonna write the name of the column that we wanna get, and this one is inside the columns variable. So I write columns, and now I run this one, and we get this slice from 0 to 9, and is here. So we have the top 1 player and we have the top 10 player, and all the data that is inside these columns that we specified in this columns variable. Okay, now let's select elements with conditions. And here a quick note, because the ilog method cannot accept Boolean series, but only a Boolean list. We have to use the list function to convert a series into a Boolean list. So we're gonna see this in this first example. And here our task is to select players with height above 180 centimeters. So here, first, I'm gonna translate this columns variable. And this one is the same as the one we saw before. So 1, 2, 3, and 4. Age is 1, and then DOP is next to age. So it's 2, and then 3 and 4. So here, we have to write the condition first. So df square brackets, then the name of the column, which is the column we want to evaluate here, height. So height underscore centimeters. Now we compare this one with 180, and this is my condition. But as I mentioned before, this is a Boolean series, and we have to convert this into a Boolean list. So here we write list and parentheses, and we use this list function. So now we write the df.ilog, then we open square brackets, and now what we're gonna do is to insert this list inside the first argument here. So it's there, and now we have to specify the columns we wanna get. So I write columns, now I press Control Enter, and here we got this data frame that has only players with height above 180 centimeters. Okay, now this final task, we have to select players with height above 160 centimeters, and these players are from Argentina. I think I didn't write it here, but anyway, it's from Argentina. So this is condition number 2, and now condition number 1, which is height above 180 centimeters. We have it here, so I copy this one, and now I paste it. And now condition number 2 is the nationality equal to Argentina. So I write nationality, then here, instead of greater than, I write equal to. Now we compare this with Argentina. So I write Argentina. And now we add these parentheses. So condition 1 with parentheses, and now condition 2 with parentheses. And in the middle, we write the AND operator. So now we have to make this a list. So I write list, open parentheses. And now what we have to do is to write the df.ilog method as usual. Now I open square brackets and I insert this list here as my first argument. So here I wrote it, and now I want to get all the columns. So I write the column sign, which is this one. Now control enter, and here we got all the players with height above 180 centimeters, and these players are from Argentina, as you can see here. And that's it. I hope you successfully solved these exercises. Okay, in this video we're gonna learn how to set new value for a cell in a data frame. And we're gonna start by importing the pandas library and also reading the CSV file and doing the changes we made in the previous videos. So here I run these 3 first cells, and now we have this data frame with these 7 columns we selected before and with the short underscore name as index. So now I'm gonna scroll down and we're gonna see the first example. So let's see how to set a value to one cell. And now let's say we want to update the height of the player Lionel Messi. So here I first have to locate the height of the player. So I write df.log, now open square brackets, and now I write the name of the player, in this case this one, and then we have to write the name of the column. So is this the name of the column? And now I write it here, so it's here now. And now we have to press Ctrl Enter, and the current height is 170. And now let's say we want to update this to 175. So we only have to write equal and then 175. And then we press Ctrl Enter, and if we show this data frame here, we can see that the data frame has a new value inside the index l.messi and height underscore cm column. So here it says now 175, which indicates that this data was updated. Okay, now let's see how to set a value to an entire column. So let's say that we want to update the height of all the players to 190 centimeters. So we can do that by using some things we've seen in the previous video. So first we have to locate the whole column, and we have to use the log method. So here I write df.log, open square brackets, and now to get all the rows we have to use the column. So here I write column, and now I write comma, and this indicates that we're gonna get all the rows. So now I write the name of the column I want to get. In this case, it's going to be height, because we have to set the height to 190. So I copy this. And now I copy height. Now paste it here. And now we write this equal to 190. So first I'm going to show you what this is going to return. And here we can see that we get the rows of this height underscore cm column, and these are all the rows because we use the column here. So now we set this equal to 190, and all this data is supposed to be 190. So we run, and now I'm going to show this data frame, and now you can see that all the data inside the height underscore centimeters, it's 190. So here we updated all the data inside this column. Okay, now let's see how to set a value to an entire row. And this is similar to setting a value to an entire column, because we're going to use the colon sign. So it follows the same idea. And here our task is to get all columns that correspond to a player ranked last in FIFA. So here I'm going to show you the data frame. And as I mentioned before, the player listed first in this data frame is the best player according to this FIFA game. And the last one is the worst player in this FIFA game. So in this case is this one, Pan Simin. And we have to get this element, and we can get this element with the ilog method. So we write ilog, and now we can write the name. We can write the name of the index. So in this case, it should be this one, 18,000. And here I can copy this one, so I can paste it now. But we can also use negative index. So here, instead of writing this number, we can write -1. And -1 represents the last element in a list, or in this case, in these indexes. So now we have to write comma and write the name of the columns we want to get. But in this case, I want to get all the columns. So we write the column symbol, which is this one, and we're going to get all the columns here. So I press Control Enter, and this is all the data about this player. So we're going to update this data, and now I want to update with null values. And to set null values, we have to use the NumPy library. So first I import NumPy as np, and now to create null values, we have to write np.nan. This nan represents null values. So here I run, and as you can see here, well, only says nan, but if now I set this equal to this data here that we got by selecting with ilog, we can update the values here with null values. So I run this, and now let's see what happens. I'm gonna show the data frame, and it's here. So I scroll down until I find the last row, and it's this one. So it says Pan Simin, and we can see that it only has null values because we updated with this np.nan, and here with this ilog we located that last row. Okay, now let's see how to set value to multiple cells. So we have to set a value for items matching the list of labels. So in this case, let's say we want to update the height of 2 players. So first, as you might remember, we have to write a list with these 2 players inside this list. And I'm gonna do this here. So I write square brackets, and now I write first the first element, which is L Messi. I'm gonna update the height of this first player, and the second player is gonna be Cristiano Ronaldo. So I write it here, and this is my list with these 2 players. So now to update this, the height of them, we have to use the log method. Then we insert this list here inside, and now what we have to do is to indicate the height column. So I'm gonna write it inside square brackets to indicate this is a list, and here I opened these quotes, and now I write the name of the column. So here height underscore cm. So I paste here. Now I run this, and we get this little data frame. So now I want to update the height to 175. So these 2 values are going to be 175. So I press Control Enter. Now I show the data frame, and we're going to see that the height of Messi and Ronaldo is now 175. And the rest is 190 because of the changes we made before. Finally, let's see how to set a value for rows matching a condition. So here we want to change the height only for players with height above 180 centimeters. So first we write this condition. So we write df, and here the column we want to evaluate. So in this case, the column is height underscore cm. So we want this to be greater than 180. And now to change the values based on this condition, we have to write df.log, and inside this we have to write this condition. So this condition is going in the first argument, and here we have to add the name of the columns we want to obtain. So here I have these columns inside this columns variable, so I copy and paste it here, and now I'm gonna press Ctrl Enter to see what we get. So is this data frame with only players that have height above 180, and now we can set this data equal to 0. So all the data inside this data frame will be 0. So I press Ctrl Enter, and now I show the data frame. So now we can see that all the data for almost all the players is 0 because their height was above 180, but Lionel Messi and Cristiano Ronaldo are the exception of this rule because we changed their height to 175. So 175 is less than 180, so this condition was false and this value wasn't set to these two heights. And that's it. In this video, we learned how to set a new value for a cell in a data frame. Okay, in this video, we're going to learn how to drop rows and columns from a data frame using the drop method. So first, we run these three cells here that transforms our data frame as we did in the previous videos. So now we scroll down, and here I'm going to show you how to drop rows using the drop method. Okay, this drop method has different parameters, which means that we can use different ways to use this drop method. And here I'm going to show you one way, which is using the axis parameter. So here I'm going to start by writing df.drop. So this is the syntax of the drop method, and now I write the index or the row we want to get rid of. So in this case, this is gonna be, let's see, the first one. So Lionel Messi, L.Messi. So I wanna delete all this row. So I write the name of the index and I write it here. So this is my first argument and I write it here. So now I press comma, and now the drop method doesn't know if this first element is a row or a column. So here we have to specify in the second argument. And here we use the axis parameter. So we write axis, then equal to, and here we have to write number 0 because 0 represents rows and 1 represents columns. So if I write 0, it means that this first element, L.Messi, is a row or it's an index. So we want to drop this index L.Messi. Okay, so here now we press Ctrl Enter to run this one, and we get here this data frame, but the row that had the index L.Messi is not here. So we dropped it. Okay, now the second option is using the index parameter. So here we write df.drop, and now we use the index parameter. So we write index equal to, now open these square brackets, and now we write the name of the element, in this case L.Messi, which is this one. So I copy and paste here, and that's it. So we're telling this drop method to drop this L.Messi index. So here, now I'm gonna comment this out and I'm gonna run this one. So I press Ctrl Enter, and as you can see, we get the same data frame. So we get the same result that we got here with the df.drop, but with the axis parameter. So here we got the same result. So you can choose any option you want. And now let's see the second example. And in this case, we have to drop 2 or more rows and update the data. And to update the data, we use the in-place parameter. So here we write df.drop. Now we open parentheses, and here we write the name of the elements. In this case, I want to get rid of the first and second rows. So in this case, the row L.Messi and Cristiano Ronaldo. So I'm gonna delete these two rows. So I write first the square bracket that represents a list. And now here I write first the name L.Messi. And now I paste it here. And the second element is gonna be Cristiano Ronaldo. So I copy and paste it here. And by the way, we open a list here because we're working with 2 or more rows. So we have 2 or more elements, and that's why we have to write this list. And now we have to specify that these are rows or indexes. So I write axis equal to 0. And then to update this data, we have to write in place equal to true. And here we're gonna update the data because we're using this parameter. Before we didn't update the data because here the drop method only creates a copy. So to save all the changes we make, we have to use the in place parameter. So here now I run this one, and as you can see, we don't get anything. But if we now print this data frame, we can see that the rows Messi and Ronaldo are gone. So the first row here is Neymar Jr. Okay, now let's see how to drop columns with the drop method, and this is similar to dropping rows. So first, let's see how to do it with the axis parameter. So we write df.drop, now parentheses, and the column I want to delete is the long underscore name. So I want to delete this column, so here I paste it. And now I have to specify the axis. So we tell the drop method that this is a column. So here we write axis equal to 1 because 1 represents columns. And now we run this one, and as we can see here, this data frame starts with the H column. So this means that the long underscore name column is not there. And now let's do this, but now using the columns parameter. So here it's the columns parameter. And now I use df.drop, and here open parentheses, and now I write column. So this is the parameter. And now equal to, and here I write the name of the column. So here I paste this column, and that's it. That's all we need. Because when we use the columns parameter, the drop method knows that this element long underscore name is a column. So that's enough. And now I'm gonna comment this out, and here I run, and as you can see, we don't have the long underscore name column. Okay, now let's see how to drop columns by position, and in this case we want to drop the last column. So the first thing we'll have to do here is to locate the last column, and we can do it by using the columns attribute. So here I write df, and now I write the columns attribute. And here I open square brackets twice, and if I want to get the last column, we only have to locate it here. So this is not the original data frame, so I have to write it here, df. So now let's find in which position is this club column. So this one is position 0, then 1, 2, 3, 4, 5, and 6. So this club is in the position 6. So now I delete this, and here I write 6. So if I run this, we get this result, and it has the club element or the club column. So it's fine, this approach, but what we can do now is to use negative numbers. So if we write -1, this means that we want the last element. And this is much better than using the 6 that we had before, because sometimes the last element is not 6, but 7 or 5, depending on how many columns we had before. But if we write -1, we can make sure that the last column is going to be selected, because -1 is always the last column. So here I run this, and here you can see that we got the same result. So it's working fine. And now to drop this column, we have to use the drop method. So we write df.drop. And now I open parentheses as usual, and now I insert this one here, and now I add the axis. So we tell the drop method that this element is a column. So here axis equal to 1 is column. So now I press Control Enter, and as you can see, we don't have the club column anymore. So we deleted the club column. And now let's check the last example, and here we have to drop 2 or more columns and then update the data. So this one is simple. We already did it, but with rows. So we only have to write df.drop, and now I open parentheses. And since we want to drop 2 or more columns, we open square brackets that represent a list. And now here I write the 2 columns, and in this case it's going to be the columns long underscore name and DOB. So here I paste this one, and the second is DOB, so date of birth. And now these are the 2 columns that we're gonna delete. So here we add axis equal to 1, which indicates these are actually columns. And now we add the in place parameter, so we update the data and we don't create a copy. So here it's ready, and now we press Control Enter, and we didn't get anything. But if now I print the df data frame, we can see that the long name column and the DOB column are not here. And that's it. In this video, we learned how to drop rows and columns using the drop method in Pandas. Okay, in this video, we're gonna learn how to create random samples using the sample method. So first, I'm gonna import Pandas and run these 3 first cells. So here I run these cells, and now we have the data frame ready. So now I'm going to show you how the sample method works in Pandas. So the sample method helps us extract some random elements from a data frame and also a series. And this can help us when we want to analyze a small portion of our data frame. So here our first example is to extract 10 random elements from the nationality column. So here in my data frame, I have this column named nationality, and here we have the countries where these players were born. So what we're going to do is to get 10 random elements from that column. So here we have to write first the name of the data frame, which is df, then square brackets, and here I'm gonna copy and paste the nationality. So here, nationality, and now we have to write that sample and then parentheses. And inside we have to specify the number of elements we want to extract from this data frame, or in this case, this series. So in this case, I want to extract 10 random elements from this series. So we write 10. And that's it. So if I run now, you can see that I get 10 random elements from this data frame. So here I get 10 soccer players, and also here the nationality. So this is the index and these are the values. And now if I run again, you will see that we're gonna generate other 10 random elements. So let's see, I run, and here we have another 10 elements. And now here we run again, and you can see that we generate 10 random elements every time we run this cell. Okay, now we can control the random number generation here with the sample method by writing the operator name random underscore state. So here I write random underscore state, and now we have to write any number we want. For example, I write the number 99, and now if I run this, we get new 10 random elements. But if I keep running this, we can see that these 10 random elements remain the same. So they don't change no matter how many times I run this cell. So this is how the random state works. But if now I change the number here, for example, I write 1, now this is another random state, and we're gonna get another 10 random elements. So I'm gonna leave it with 99. So this is my random state, and that's how the sample method works. So now let's see the second example. And in this example, we have to extract a random 20% sample of the data frame. So here I have the original data frame, and this one has 18,000 rows. So if we want that 20%, we just have to divide the number of rows by 5. So here, let me show you. We write df.sample, then we open parentheses, and here we could write this number divided by 5. So this divided by 5, and we get our sample. But now we can do something different. We can add a new parameter to specify the portion or the fraction we want to get. So let me show you here. We need to introduce the frac parameter. So I write frac, and this stands for fraction. And now I write equal to, and here I write 0.2, so 20%. Now I run this, and here we get the 20% portion of this original data frame. So here, this is 3,600 rows, and yeah, that's like this 18,000 divided by 5, so the 20%. Okay, now we can control here the random number generation. So here we can add this, let me see here, random underscore state. So this is the parameter that helps us control the randomness of the sample method. So we write random state, then equal to, and in this case, I'm gonna write any number, let's say 12. And now I run, and now I get the 20% with the random state 12. And if I keep running here, we get the same 20% sample. So it remains the same. Finally, let's see how to increase the sampling rate, which is known as upsampling. So when we want to increase the sampling rate, we have to specify the frac parameter greater than 1. So for example, if frac is equal to 2, this means that we want to get that 200% of the original data frame. So we want to double the number of rows. But here, keep in mind that when the parameter is greater than 1, so for example, when we want to double the number of rows in a data frame, we have to set the replace parameter equal to true. So that's like a rule. Every time we set the frac parameter greater than 1, we have to set the replace parameter equal to true here. So keep that in mind. And now I'm gonna do this here. So I press df, now that sample, and now open parentheses. So now we want to double the number of rows in this data frame. And now we have to write frac equal to 2. And here I'm gonna add the replace parameter because here 2 is greater than 1, and we have to follow this rule. So 2 greater than 1, and parameter has to be equal to true. So now here what we have to do is to add this new parameter replace equal to true, and that's it. So now we run this one, and here I get an error because I didn't write this sample correctly. So now I fix it, and now I run this one, and here we got this data frame. And this data frame should double the number of rows of the original data frame. So let's check it out. Here there are 36,000 rows, and let's see how many rows the original data frame had. And here 18,000. So yeah, it doubled the original number of rows. And now here again we can add a random state in case you want to control this. So random state, and here you can write any number. So I'm gonna write 99 in this case. Now I press Ctrl Enter, and this data frame or this sampling that we're getting is gonna remain the same. So it's not going to change, as you can see here. And that's it. In this video, we learned how to create random samples with the sample method. Okay, in this video, we're gonna learn how to filter a data frame using the query method. So we're gonna start by running these 3 cells, and now I have this data frame that we created in the previous video. So here is the data frame, and now I'm gonna show you how the query method works. So the query method help us filter a data frame the same way we did in previous videos. But in previous videos, we used something called Boolean slicing. But in this case, we're going to use the query method, and this is a different syntax. So I'm going to show you here, and first, let's solve this task that says select players older than 34. So to solve this with the query method, we write df.query, then we open parentheses, and here we open these quotes, and inside we write this condition. So first the name of the column, which is age. Let me see here, so age, and we have to compare this with 34. And as you can see, this syntax is different from the syntax we've been using with the Boolean slicing. But let's try it out. So here, let's run this one. And in the data frame that we got, here the ages are greater than 34. So here we have 37, 36, and yeah. So we successfully filtered this data frame with the query method. And now I'm going to show you how we will do it with the Boolean slicing in case you don't remember how this works. So with the Boolean slicing, first we have to create a condition. So here we write df, then open square brackets, and now we write the name of the column. So here age. Now we compare this with 34. So we write greater than 34. And now we put this inside square brackets. So here I write df square brackets, and this condition is inside. So here this is called Boolean slicing, and this is gonna return the same data frame we get here with the query method. So now let's check it out. Here I comment this out and I run this one, and this is the same data frame we got before, but now with a Boolean slicing. So both have the same result, but different syntax. And you can choose the one you find most practical or the one that you find easy to remember. Okay, now in this second example, we have to select players older than 34 from Italy. So this is some kind of multiple condition, and we're gonna do this with a query method. So here I write df.query, now parentheses, we open these quotes, and inside we write the two conditions. So here we only write the name of the column, so age greater than 34, and now we write the second condition, so nationality here equal to Italy. So here Italy should be inside quotes, but since we already used these double quotes here, we have to write single quotes to avoid any conflict between these two. So here I used single quotes for Italy, and now it's fine. So here we have condition number 1, which is this one, and this one is condition number 2. So now we have to add an operator, and in this case we have to add the AND operator. So we have to do this because we want to satisfy both conditions. And as you might remember, the AND operator is represented by this symbol that I'm writing right now. So we've been using this symbol, and in this case with the query syntax we don't use that symbol but a different symbol. So here instead of writing that symbol we only write the word AND. So here we said this condition and this other condition. So that's how it works with the query method. So now it's ready, and now let's run this one. And here I got the data frame, and in this data frame the age of the players are greater than 34, and all the players are from Italy, as you can see here. So we successfully filter this data frame with this multiple condition. Okay, now as an exercise, you have to write the equivalent Boolean slicing of this query method. So you have to do something like I did before here. This is the equivalent of this query method. So you have to do something like this. And you can pause the video, and then to check my solution, you can download my script that is in the notes of this video. Okay, now in this third example, we have to add a not operator to the first example. So let me copy the code of the first example, which is right here. So I copy this one. Now I paste it. And now we have to add a not operator. So far, the not operator that we've used is this one. So we've used this operator in this course so far, but now in this query method, we have to use a different operator. So instead of writing this symbol, we have to add first parenthesis, and now here write the word not. So this is the not operator, and this is being applied to the age greater than 34. So if we set not this, we're gonna get age less than 34. So let's check it out. I run this one, and as you can see in this data frame, all the players have age less than 34. So this is how we do it with the query method. And now you have to write the equivalent Boolean slicing of this query method. Okay, now in this task, we have to convert the height to meters and then select those with height above 1.8. So we can do that with the query method. We only have to write df.query, now parentheses, and inside quotes, we have to do this operation. We have to transform the centimeters to meters because the height now is in centimeters. So to convert this to meters, we only have to write the name of the column here and then divide it by 100. So here we have the height in centimeters, and if we divide it by 100, we get the height in meters. So now what I'm going to do is to compare this with the height here, 1.8. So I write 1.8, and now this query is ready. So we can run this one, and as you can see in the data frame, all the players have a height above 1.8. All right, now your task is to write the equivalent Boolean slicing of this query we created here. Okay, now our last task is to select players that were born after 1990. So to do that, first we have to check the data types of the columns. So here I'm going to see the data types of all of these columns. So here I write df, and I'm going to use an attribute that we learned in this course, which is the d types. So this one helps us get the data types of all the columns in this data frame. And now I'm going to see this one, but here above. So I run this, and as we can see here, the date of birth, so DOB, has a data type object. And this isn't good because here the date of birth, so DOB, is time. So it has the year, the month, and I think the day. And this column should be a data type. And we can convert the data type of this column by using a method that is called asType. And I'm going to show you here how it works. So first we write df, then the name of this column, DOB, and now we write asType. So this is a new method. We open parentheses, and here inside we write the type we want to convert to. So here I write date time 64, and this is a time type that is common in pandas. So here this is my time type or date time type, and now I'm gonna override here this DOB column. So it's here. So now I'm updating the data type of this column. So we do this because we want to extract the year of this column, and we can only do that if this column has a date time type. So that's why we're converting this column to a date time type. And why we want to get the year? Because here in this task we have to select players that were born after 1990. So if we compare the years, only the years, we can know which players were born after 1990. Okay, and once we convert this data type, what we have to do is to get access to the year attribute of this column. And we can do this by writing the name of the column. I'm going to show you here in this cell. So here, df square brackets DOB. And then to get to the year, we have to write first the DT attribute. So this is some kind of date time. And now to get to the year, we write that year. So this is the year attribute. So now I'm going to run this, but first I have to convert the column to date time type. So here I paste it. And now I run this one. And as you can see here, I got only the year of each date. For example, Cristiano Ronaldo was born in 1985. And here is the year. So we extracted only the year by using this year attribute. So here we can do the same, but with a query method. So I'm going to show you how to do it with a query method. So first we write df query, open parentheses, then this quotes, and inside we have to write the name of the column. So instead of writing this series syntax, we have to write only DOB. So here we have to write DOB, and then we have to get access to the DT attribute. So that DT and then that year, as we did here before. So it's the same, just with the syntax that we need for the query method. And then we have to compare this with 1990. So here we're saying that the year is greater than 1990. And that's my query. So now I can run this one to verify that all the players were born after 1990. So I run this one, and as you can see here in the data frame, all the players were born after 1990. For example, Neymar Jr. 1992, and this one 1991, and yeah, 1997, and we filtered this data frame successfully. Now your task is to write the equivalent Boolean slicing of this query here. And you can use this code I wrote here to help you. And that's it. In this video, we learned how to filter a data frame using the query method. In this video, we're going to learn how the apply method works in pandas. So I already imported pandas and I read this data frame that we're going to work with. So now I scroll down, and here I'm going to show you how the apply method works in pandas. So the apply method helps us apply functions or operations to a column or to a data frame. We can apply built-in functions as well as our own functions. So I'm going to show you how to do both. First, we're going to use the numpy function and apply it to a series. So in this case, we're going to apply a function to the age column or the age series, so this one. So to do that, we write first df, and then we write the name of the series, so age, and then we apply this method. So we write dot apply, and now we open parentheses. So now inside parentheses, we have to use this function. And in this case, I'm going to use a numpy function. So first, I'm going to import numpy as np. So here I have it. And now we have to write the function we're going to use here. So in this example, I'm going to use the square root function. So here we write np.sqrt, which stands for square root. So now if we run, but first let me show you how this looks like without the apply. So here I run, and here we have the ages of these players. But now if we apply this function, we're going to get the square root of each age. So now I press Ctrl Enter and we get the result. So this is the square root of the age of Messi, for example, and this is the square root of the age of Ronaldo. Okay, and that's how you apply a function to a series. And now I'm going to show you how to create your own function and apply it to a data frame. So here I scroll down, And now we're going to create our own function that calculates the BMI of a soccer player. So here I write def calculate and then BMI. So now I write the parameter here and it's going to be row. Now I press here the column symbol. Now I press enter and here I write return. And now I'm going to write the operation that I want to perform here. So to calculate the BMI, we have to divide the weight in kilograms by the square of the height in meters. So here we have to convert this height into meters and then get the square. So here I scroll down and now I'm going to create this formula. So the weight divided by the square of height, so meters, and here this number 2. And now here in the formula I'm going to write row, which is this one. By the way, this represents the data frame. I just didn't write df, so to avoid any confusion with this df data frame, so I wrote row, but this represents like the data frame. So now row, and then we open square brackets. So we're gonna make a selection of a column. And now here I'm gonna select the weight column. So here I'm gonna copy the name of this column. And now I paste it here. And now here we have to introduce the other column, which is the height. So I copy this one. And now this is in centimeters, so we have to convert this to meters. So we divide this by 100. And now to get the square, we have to open parentheses here. And now write this symbol twice, which is multiplication. And if we write it twice, we get the square. So here, if I write 2, it means that we get the square of this number. So now, if I want to divide this, I write this operator, and now we get the weight divided by the square of the height in meters, as you can see here. So now this is ready, and I'm gonna run this one, but first I'm gonna delete this, and now it's ready. So I press Ctrl Enter, and now I can apply this function using the apply method. So here I'm gonna write the name of the data frame, df, then dot apply, open parentheses, and inside I can specify the name of the function, as I did here with this numpy function. But in this case, I'm gonna write the name of my function. So calculate underscore BMI. So I write it here, and now I have to add one more parameter, which is axis. And this means how we want to make this operation, or how we want to apply this function. So here in our function, we want to make operations with multiple columns. So here I have column number 1 and column number 2. So we want to make some operations between 2 or more columns. This is why we have to write here axis equal to 1. In this way, we can make operations with multiple columns, as we are specifying here. So now it's ready, and now I'm going to run this cell. And here you can see that we get the BMI of each soccer player. So here I have 24.9 for Messi and 23.7 for Ronaldo. And that's it. In this video, we learned how to apply functions to a series and to a data frame. Okay, in this video, we're going to learn how the lambda function works and how we can use this function inside the apply method. So first, I imported pandas, and now we have the data frame as we had it in the previous videos. And now I'm going to scroll down, and here I'm going to explain you how to use the lambda function. So first, to give you a simple explanation, let's start by creating the average or the basic function we learned in the Python crash course. So okay, let's create a Python function that sums two values a and b. So here I write def, then sum underscore values, which is the name of my function. Now I introduce the parameters, so a and b, then colon, and then I want to sum these two parameters or these two values. So I write a plus b. Now I assign this to a variable which I name x, and then I return x value. So here return this x variable which is here. So this is my basic function. So this is the function we've been using so far in this course. And now if I want to call this function, we write the name of the function and then we pass in two arguments. So here I want to sum 2 and 3. And now if I run this, I should get 5. So here I run it and now we get 5 because 2 plus 3 is 5. So now this is how the basic function works. And now I'm going to create this same function, but now using the lambda function. So here in the lambda function, we have to first write the name of the function, which is going to be, let's say, sum underscore values underscore lambda. So we know this is the lambda function. Now equal to, and here we have to first write the lambda key. So we write lambda, and now you can see that this is in green. So this is the lambda key. And now we have to write the input and then the output. So first the input. So here my input is A and B as we wrote here before. So A and B and then colon. So we write colon to separate the input and the output. And now I'm going to write the output. And the output is going to be the operation we want to perform. So in this case, A plus B. So we want to sum these two values. So here I run this one, and now we created this lambda function. So this lambda function is supposed to get two values, and then it returns the sum of these two values. Okay, now I want to show you how this lambda function looks. So I copy and paste it here, and now I'm going to show you how the average function looks. So here you can see that it says function and then the name of the function, and here it says function, but here we have lambda. So this is a lambda function, and this is just the average function or the basic function we learned. And now I'm going to apply this lambda function. So here I write parentheses, and now I pass in two arguments. So in this case, it's going to be 2 and 3. So we introduce these two values and we should get the sum of these two values. So 5. So I run, and yeah, we get the number 5. So here we created this lambda function, which is the equivalent of this function. So just a recap now, this is the input, which is the same as these parameters here. And this is the output, so what we're going to return. Then the name of the function, we have to assign it here, and this is the name. And here, this is the equivalent of the name of the function here in blue. And now you might be wondering why we need to use the lambda function. The lambda function is useful when we want to create a temporary function. So a function that we're going to use only once, and then we're not going to use anymore. So that's one of the cases when we use the lambda function over the average function. And also sometimes we use it when we want to simplify things. So it's like a one-liner compared to the average function that has more lines. So it's much simpler. Okay, now I'm going to show you how to use the lambda function with the apply method. So here I scroll down, and our first task is to use the lambda function to convert the height series to meters. So here, what we have to do is first write the name of this column. So df, here square brackets. Now I copy and paste this height underscore cm. So it's here. And now we write apply. This is the apply method. And now inside parentheses, we write the lambda key to create the lambda function. And then we write the input. So here we can write any variable. I'm going to write the letter X, and this is going to be my input. And now I write colon, and now I have to write the output. So in this case, the output is going to be x divided by 100 because we want to convert centimeters to meters. So here, x divided by 100 is how we convert centimeters to meters. And this x represents one row of this series. So we're gonna apply this lambda function to each row in this series. So now I'm gonna show you how this works. So I run this one and we have the height, but now in meters. So before Messi was 170 centimeters, but now it's 1.7 meters. And that's how to use the lambda function with the apply method. And in this case, we don't need to set a name for this function as we did before here. We set a name of the function, but here, when we combine the apply method and the lambda function, we can leave it as it is without the name. So now I'm going to show you an alternative to this apply method. So how we can achieve this same task without the apply method. So this is really simple. We only have to write the name of the series and then divide it by 100 to convert this to meters. So now I comment this out and now let's test it out. So here I run this one and as you can see, we got the same results. And now you might be asking yourself why we need to use the apply method if there is a simpler alternative. So in this example, the apply method looks unnecessary, but there are some cases where this apply method with the lambda function is really useful. And I'm going to show you this in the following example. And our second task is to use the lambda function to convert the long name series to uppercase. So here, let's have a look at this series. So I print this data frame. So this long name column has the full name of the soccer players in uppercase and in lowercase. But here, I'm going to delete this one. We want to get the full name in uppercase. So we can do that with the apply method and the lambda function. So we write first the name of the series or the column we want to get. So this case is long underscore name, which I have to paste it here. And now we write apply, now parentheses, and now I write lambda. So I'm going to use the lambda function and I write the variable. So x, this is my input, and now the output is going to be x. And here we're going to use the upper method. So we learned this method before and we only have to write upper and then parentheses. And here we can use this upper method because this x is a string. And why this x is a string is because here this long name series contains letters, so contains strings. So as you might remember, this long name contains the full name of a soccer player and that's a string. So here the x represents one element of that series. And this means that this x is a string. So strings has this upper method and that's why we can use the upper method. So here I run and now as you can see in the result, the names are in uppercase. Okay, and now I'm going to show you an alternative to achieve this, but now with the str attribute. So here I have to write the name of this series, but now we cannot use this upper method right away because if we paste this, and now I'm going to comment this out. So now if we do this, we're going to get an error because here this is not a string, but this is a series. So here, when we do this apply with lambda, here this x represents a string because this is an element inside this series. So that's one of the benefits of the lambda and the apply when we use them together. This x represents one element of this series and one element of this series is a string because these are names. However, here, this is a series, so we cannot use the upper method because the upper method only works with strings. So here, what we have to do is to get access to the string attribute. And we do that by writing .str. So this is the string attribute. And now we can use the upper method because we got access to the string attribute. So now if I run this, we can see that we got the full name in uppercase. And here we could see one of the benefits of the apply method when we use it with a lambda function. Because here, when we use the lambda and apply, we didn't need to specify any attribute. But here we have to specify an attribute. And that means we have to remember all the attributes an object has. And sometimes when you're a beginner, that might be complicated. I remember many times that I didn't remember all the attributes, and sometimes I did something like this, and as a result I got errors. So here, when you use the apply and the lambda function, it's much easier. At least it's easier to remember than many attributes here. So here, I'm going to show you another example, and in this case, we have to use the lambda function to get the year of the DOP series. So here, I'm going to show you this data frame again. And the DOP column or DOP series is this one. So here we have the date of birth, and we want to extract only the year. So this one. So to do that, first, we have to convert the data type of this column into a date. So if we get the data types here, we will see that the DOB is an object. And this should be a datetime type. So we can convert this data type into a datetime by using the asType method. So here, I'm going to write df. Now the name of this column, which is DOB. And now I write that asType. And this method allows me to convert that data type. So in this case, I want it to be datetime 64, which is the standard datetime in pandas. So now I'm going to overwrite here this column, and I'm going to change that data type. So here I run this, and now if I show the type, we're going to see that it changes. So here now the date of birth column has a different data type. So in this case it's datetime. And now this is ready. So here I'm going to delete this one. And now that this is a datetime type, here we can extract the year. So now what we have to do is to write the name of this column. So df dob, and then apply lambda, and now the input, which is the x, now colon, and now x dot year to get the year. Since this is a datetime type, we can get access to the year attribute. So we only have to write that year, and that's it. So here we can run this one, and as you can see in the result, we get only the year. So for example, Messi, here we have the date of birth that only represents the year, and here Ronaldo was born in 1985, and so on. So here we did this with the apply method and with the lambda function, but here there is an alternative using attributes. So we only have to write the name of the column followed by the DT attribute that represents the date time. So D is date and T is time. And now we can get access to the year. So here I'm going to run. I'm going to comment this out, and now I run. So I did it, and now here we got only the years. And as you can see, it's the same result. So here we can see again one of the advantages of the apply and lambda function, because here we didn't have to use the DT attribute. But if you wanted to use the alternative, you need to know that there is a DT attribute, because if you don't know about this attribute and you only do this, you're gonna get an error because here this again is a series and you need first to get access to the data type. So here we have to write DT, and now after that year, and that's how it works. But if you don't have any idea about this DT, you wouldn't be able to do it this way, but only with the apply and the lambda function. So here is one of the benefits of this lambda function with the applied method. Finally, in this task, we have to apply the lambda function to a data frame in order to calculate the BMI. So we did this before to calculate the body mass index, but in this case, we're gonna do it with the lambda function. So first we create this lambda function, and here I'm gonna create a function. So first the input x, and now the output. So the output is gonna be here x. Now we open quotes, and we need two columns. So the first one is the weight, and the second one is the height. So here I'm gonna print the data frame so I have the columns. So here I copy first the weight and I paste it here. So here we're selecting the weight column. And now I'm gonna do the same. So I copy this one and I paste it here. And now I copy the height column. So here we have the weight and the height. So now I convert the height to meters. So I divide it by 100. And now I use parentheses, and here this symbol twice with the number 2 to get the square. And now we have to divide the weight by the height. So here I write this symbol, and now we have this, but here we have to add a parenthesis. So now it's ready. So we have this lambda function, and now we have to insert this inside the apply method. So write df.apply parentheses, and now we insert this as first argument. And as a second argument, we have to use the axis parameter. So this axis equal to 1. So here now is ready, and I'm gonna run this one to see the results. So here I run it, and we got the BMI of each player. So here Messi has 24.9 and Ronaldo has 23.7. And that's it. In this video, we learned how to use the lambda function with the apply method. Alright, in this video, we're going to learn how to make a copy of the data frame using the copy method. So here I have the data frame that we're going to make a copy of. So is this one. And now I'm going to show you how to do it. So we're going to use the copy method, and here to make a copy of this data frame, which has the name df, we only have to write the name of the data frame, so df, and then dot copy. Now we open parentheses, and here by default the deep parameter, which is a parameter of this copy method, is set to true. So this means that all the modifications that we make to the data in the original data frame is not going to be reflected in the copy, and vice versa. So here I'm going to show you with an example. If I make a copy, and now I set this copy to df_copy, and now I run this, and if now we update a value of this original data frame df, so let's say we want to update the height of Lionel Messi. So we do df.log, then square brackets, then l.messi. Now the name of the column, which is height here. So I copy and paste it. So I paste it here. And now if I set this to another value, so let's check. Right now Messi has 170. So if we set this to 180, let's see how this is going to affect the copy and also the original data frame. So if we now print the df data frame, which is the original data frame, we're going to see that here in the height we have Messi, and the new height is 180. So this makes sense because we just updated this height. But now if we print the copy data frame, let's print it here, we're gonna see that the value of this height is still 170. So this means that we created an independent copy. So this df underscore copy is independent from this df original data frame. So any update we make to the df data frame is not going to be reflected to this df underscore copy because both are independent. That's usually the behavior we expect from copies. But if for some reason you want that the copy and the original data frame are dependent, you have to set this deep parameter equal to false. And I'm gonna show you here below. So here I copy the code. We're gonna make a copy, but in this case, we're gonna modify the deep parameter and we're gonna set it equal to false. So here I write deep equal to false, and this is gonna create something called a shallow copy, which means that all the changes that we make to the original data frame will be reflected to the copy. So both are gonna be like dependent. So now I'm gonna update a value, and in this case, let's update the height of Cristiano Ronaldo. So I write df.log, and now I write Cristiano Ronaldo, and then we have to write the name of the column we want to update. So in this case, it's gonna be the height column. So here I copy and paste it. So now, as we can see here, Ronaldo is 187, and now we want to change this to, let's say, 200, so 2 meters. Okay, now before I set this new height, first I'm gonna make the copy. So here I make this shallow copy, and now here I'm gonna name it shallow underscore copy. So now I run this again, and now this copy was created, and I'm using this df underscore shallow underscore copy variable. And now I'm gonna set this height of Cristiano Ronaldo equal to 200. So now I run this one, and now let's see how the df data frame and the df underscore shallow underscore copy data frame look. So here, let's print them. So first df, and now we can see that in the original data frame, here the height of Cristiano Ronaldo is now 200. And this makes sense because here we set the height to 200. But now if we print the shallow copy here, we're gonna see that the height of Cristiano Ronaldo in the shallow copy is equal to 200. So this means that the changes we made in the original data frame, df, were also reflected in this shallow copy. So this df and df underscore shallow underscore copy are dependent. And this happened because we set the deep parameter equal to false. Okay, now I'm gonna show you another way to make a copy. And in this case, it's gonna be with a simple assignment. So here, this works like this. We want a copy named df underscore new underscore copy, and we set this equal to df. So this is the simplest way to make a copy with a simple assignment. And now we run this, and now let's update another height, but in this case of Neymar Jr. So we write df.log, now the name Neymar Jr., and now the height column here, I quickly copy, and now I paste it here. So now let's see the height of Neymar Jr. is 175. So let's update this to 190. So we update the original data frame, and now let's compare the copy and the original data frame. So here I print the df, and now we can see that the height of Neymar Jr. is 190. And yeah, that's correct. But now if we print the copy, df underscore new underscore copy, we're gonna see that here the copy was also updated. So the new value is 190. And this means that this copy is a shallow copy because all the changes we made in the original data frame were reflected in this copy. And this is the equivalent of making a copy using the copy method with div equal to false. So just keep that in mind when you do something like this. And that's it. In this video, we learned how to make a copy of a data frame using the copy method. Welcome back. In this video, we're going to see different ways to make pivot tables. If you're an Excel user, probably you made many pivot tables in the past. In Pandas, we can also make pivot tables, and in this case we use two different methods, the pivot method and the pivot_table method. In this video we're gonna see the difference between the two of them. So first, let's see what's the pivot method. So the pivot method reshapes data based on columns values, and it doesn't support data aggregation. So this means that this is not the regular pivot table you will see in Excel, because you can only reshape data with the pivot method and you cannot do anything else. To explain you better what the pivot method does, I'm going to show you an example. So here we have a little data frame, and this one has 6 rows and 4 columns. And as you can see here, there are many duplicate values. For example, in the column foo, the 1 value is repeated at least twice, and the same goes for the 2 value. Also, in the column bar, you can see that the A, B, and C is duplicated. So when we have this type of data frame, we can reshape it to have a different view and to make a better analysis. In this case, we can use the pivot method, as I'm going to show you right now. You only have to write the name of the data frame followed by the pivot method, and then specify 3 arguments. So the first one is the index. In this case, I'm going to reshape this data frame choosing the column foo as an index. This means that the column foo will be in the position where is right now the numbers from 0 to 5 on the left. Next, you have to define the column. So these are the new columns that we're going to see in our new data frame, the one that we're going to reshape. So in this case, I'm selecting the data inside the bar column as new columns. This means that A, B, and C will be the new columns in our new data frame. And finally, we have to choose the values we wish to show in this new data frame. So in this case, I'm choosing the base column, so all the values inside there will be shown in our new data frame. So this is the column that I'm selecting. And now I'm going to show you the result of this pivot method. So here it is, and as you can see here, we have the foo in the index, as I told you before, and the A, B, and C that are data from the bar column now are columns in this new data frame. Also, all the data inside this base column is the only data that is displayed in this reshaped data frame. And now let's see why it's sorted this way. So why 1 is here, 2 is here, 3 is here, and so on. So here the value is defined by the index or row and the column. So between 1, index 1, and column A is 1. And why that happens? Because if we go to our previous data frame, or the original data frame that is here, we can find that here is 1, A, and the value that corresponds to that pair is the number 1. So let's pick another one. For example, 5 here. We have 2 and B. And if we go here to our original data frame, we have that 2 and B. The value that corresponds to that pair is 5. So that's why this value is here. And that's how this new data frame was reshaped. Okay, And finally, we have the pivot underscore table method. And this one creates a spreadsheet style pivot table. So this is similar to the pivot table that we will find in Microsoft Excel, for example. And this one supports data aggregation. And to explain you more about the pivot underscore table method, as well as the pivot method, we're going to see some examples in the next video. And this time, we're going to write some code so you can understand much better what we're doing. All right, now it's time to see how the pivot method works in action in pandas. So first, as usual, we import pandas as PD. So here I import this library, and then we're going to use a different dataset to work with this pivot method. So to read this dataset, we use the pd read underscore CSV method. And inside parentheses, we write the name of this dataset. So in this case is gdp.csv that you can find in the notes of this video. So this is the new dataset, and now let's have a look. I'm going to run this one, and as you can see here, we have data about GDP per capita that is in this column. And basically, this is how the GDP grow over the years for each country. So here I'm gonna tell you which are the columns we're going to use for this example. So first, we're gonna use the country column that contains data about different countries. Then we're going to use the year column that, well, contains different years, and the GDP per capita that it's in this column. So basically, what we want to do in this exercise is to obtain a different view of our original data set. So this data set that we're reading here with pandas has this view, but we want to get a different view to have a better analysis. So the goal of this exercise is to see the evolution of the GDP per capita over the years for each country. And then we're going to put the country names in the columns. So the only data we're going to show in our new data frame is going to be the GDP per capita that it's here. So I'm going to show you now this with code, and let's write it here. But first, let's assign a variable to this data frame. So here I'm going to write df underscore GDP. So this is the name of my data frame, and now I'm going to show it, and it's here. So now I'm going to copy this data frame, and to use the pivot method, I'm going to paste this one, and now write that pivot. Now we open parentheses, and now, as you might remember from the previous video, we have to introduce 3 different arguments. And if you don't remember the 3 different arguments we have to introduce here, you can only press the Shift and Tab keys on your keyboard, and you will get this. And here you can see the 3 arguments I'm talking about. So first, we have to write the index argument. So we write index, and as I told you before, I want the year column to be the index of my new reshaped data frame. So I'm gonna set this year as the index of my new data frame. So I write here year. Next, we write comma and press Shift and Tab to show this. So the second argument is the columns. So we write columns, then equal and open quotes. So here, as I told you before, I want the countries here listed in the country column. I want each country to be an independent column. So for example, here, let's say we have the United States. So I want the United States to be column number 1, then column number 2, China, then Australia, then